can find is that the physical beneficiation by conventional methods, another way the reduction roasting. You can find the conventional reduction roasting is very complex and maybe cost effective or not, and it needs a lot of instruments to be designed. Yeah, what is the way forward? The alternative to this is the reduction roasting and the magnetic separations. And reduction roasting, what we do is reduce the ores normally by coal or charcoal in the lab scales, and coal is also a mineral. After the reduction roasting, we do the limbs, WIMS to get a product. And reduction roasting, why we do is that it increases around 15 to 20% the extra yield, increases the grade of the concentrate, reduces the grinding energy by around 20 to 25%. Handling of the residues is easy and does not need tailing ponds, and transportation pipeline is very easy and easy to make the pellets. Okay, this is what the reduction roasting process followed. Our aim was how we can find an alternative substitute for coal. Rather than by going by coal, we can think of the alternative methods. We have tried the cow dung. And you know, the cow dung, the present process is the environmental friendly, renewable, abundantly available, and economically viable reductant that is suitable for the reduction roasting and complex and low grade ores. And these are some characteristics of the cow dung. And this is after process products have been got. We have done the characterizations. And what is the cow dung is reductant better than the charcoal. Cow dung is the reduction roasting. The Indian is 56.2% iron. It can give a concentrate of 64% Fe at 700 degrees centigrade. Time is 45 minutes and reductant to ratio is 0.25 to 1%. Under similar conditions, the conventional reduction roasting is charcoal is more. Okay, concept waste to wealth. We thought of cow dung, but cow dung has some problems, some complaints. Therefore, we thought the mineral industry waste product, the industry waste is the dolochar, and another the blast furnace flue dust, which contains significant values of carbon and significant values of iron along with them. Because they contain the carbon and it cannot be physically beneficiated, neither the iron nor the carbon can be separated by the dolochar and blast furnace flue dust. Therefore, we thought, why will not use this waste of the iron ore industry directly for the reduction roasting, such that the carbon will be used for the reduction roasting and the iron will come in the product. In that way, we thought of the dolochar. Dolochar is nothing but the sponge iron industry waste. The dolochar name comes from the dolomite, dolo, and charcoal, char, coal, char portions. Therefore, the name dolomite, and they contain about 27.19% of the fixed carbon, which can be used in the reduction roasting process. And these are some of the characteristics of the dolochar, and where we understood this can be certainly useful because dolochar as of now is used as a waste material as a dumps or in the road making process and so on and so forth. And after going through these characteristics, we thought that carbon portion can be used and the iron can be recovered. Okay, the next is the blast furnace flue dust. I told blast furnace flue dust. This also contains significant values of the carbon and significant value of the iron, which cannot be separated or which cannot be removed physically by physical beneficiation. Therefore, we thought of this blast furnace flue dust also can be used for the reduction roasting. In view of this, we characterized that blast furnace flue dust we could get. There are good amount of carbon in the form of different iron carbides or graphite, and there are some amorphous and to some extent crystalline graphite is also there, which can be useful. And other than that, blast furnace flue dust, we also tried for the biomass briquettes. You know, in Punjab, Haryana and side, December month, they burn this biomass and it gives lot of pollutions to the Delhi side. And some of the industries, they make this biomass as briquettes, which is used for some other purpose. And we thought this biomass also can be tried as a reductant. Let us try what will happen. And we could find successfully the biomass can be used in the reduction roasting process of the low-grade iron ores, and you can see the results. And these are the some of the characteristics of the biomass and process products of the reductants iron ores. What's the way forward? Way forward is the first of all, these studies, the proof of concept that all these substitutes to the coal as a reductant. All these studies are in the TRL level of 4. Reduction ore studies is not only for the low and lean grade iron ores, but also iron rich manganese ores. In case of manganese ores, where it is iron ore, iron and manganese content is 1:1%, there also it is very difficult to physically beneficiate the iron minerals and manganese minerals from the ferruginous or iron rich manganese ores. The same reduction roasting process can also be adapted, and we have tried for one of the things for the Joda Budbil manganese ores, and these are the some of the characteristics, and where we could get achieve more than 1:3 or 1:4 the iron to manganese ratios. Thank you.
Thank you, respected Professor Mishra sir, dignitaries on the dais, dignitaries of the dais. So my previous speaker spoke about mainly on iron ore and some other aspects. So I will give you an overall view of India, low grade, beneficiation of low grade and lean grade ores of India. And my presentation is divided into 3 parts. One is what is the status, present scenario. Another is case studies, and third one is what we can do way forward, what is the way forward and policy matters. Next. Yeah. Yes, sir. Now it is. So the broad objectives of beneficiation of minerals and ores is upgradation of minerals to meet the specification of user industry. The second objective, broad objective, is to felicitate mineral industry for exploitation of our mineral resources in judicious manner. And the third one is conservation of natural resources for economic utilization. So these are the broad objectives. The significance, there is a huge significance of mineral beneficiation. You know, to meet the present demand of the raw material of industry, there is a need for enhancement of mineral production as well as utilization of low grade ores. So these are the need of the hours. So for that, beneficiation is the only answer to all these. Decrease in grade with increase in change in characteristics. As you go deeper in mine, as you go horizontally as well as vertically, there will be change in characteristic. The characteristic when you study the open the mine is not the same when you go after 5 years or 10 years. So there is a lot of variations. So for that, we need detailed characterization and beneficiation studies. Then apart from that, when you put up a beneficiation plant after erection, then there are a lot of problems to maintain metal ore production, to recover associated byproducts. When you study initially, we do not pay attention to the recovery of byproducts. So these can be solved by multifaceted way, and case specific solutions can be given. In India, what is happening in the present scenario? All the lean grade ores or low grade ores, because in nature, copper, lead, zinc, all base metals, rock phosphate, graphite, REs, bis and heavy minerals, tin, tungsten, gold. These require beneficiation. Without beneficiation, it cannot be utilized. Because why we go for excavation? Because for utilization. If you go for utilization, then these are the ores which we are adopting beneficiation presently. But as far as iron ore, manganese, chromite is concerned, we are doing very less in this. Now the time has come, we have to move ahead. So the future prospect of beneficiation is, we need to look for alumina-rich hematite ore, silica-rich hematite siliceous fines, as well as BSK, BHJ, and magnetite ores, BMQ. Then another important aspect is strategic and critical minerals. So we need to recover gold, silver, cobalt, nickel from base metal and other rocks. You know, presently in a mining school, we are doing it in copper ore on base metals. But there are gold values. Recently we have carried out a lot of exploration samples. In IBM, we are carrying out almost all the exploration samples of India for their amenability study before going for auctioning. So in that, we have found a lot of these values are associated with base metals, especially copper of Eastern India and Western India. Then pre-concentration, because if you go for lithium, vanadium, lot of lithium, vanadium bearing minerals are there associated with other ores. Say for example, in graphite, there are vanadium with mica. So we need to pre-concentrate those minerals, then we need to extract by a hydrometallurgical route for utilization. So these are the future of our country. We have to focus on this area. Then the time has come. Beneficiation of limestone. Every year, out of 300 million ton production, we are 50 million tons we are throwing away as a mine reject. So even in southern India, some still cement plant are importing the ore. So we need to look for benefiting the limestone also and bauxite. So just before going for, I would like to highlight the IBM's domain. IBM deals with the wide spectrum of minerals, almost all the minerals except fuel and atomic minerals. The sphere of interaction is very huge. We interact with private industry, exploration agency, state central PSUs and academic institutions. Our IBM has got 3 facilities. The biggest one is at Nagpur, and the second one is at Bangalore, and third one is in Ajmer. And in Bangalore, we have also a fire assay laboratory for analysis of gold, platinum, and silvers. Then mineralogical characterization and chemical analysis facilities there. So why mineralogical characterization important? Because it is important for identification, determination of textures, grain size, then chemical analysis for metallurgical and material balance. Then laboratory scale study, then pilot scale studies. So these are for upscaling and confirming the laboratory scale study in continuous scale. So these are the things we carry out. Now come to the case studies. So I'll start with gold ore. Recently, during last 3 to 4 years, we have carried out gold ores of India. You can see the tenors. So it is from 1.8 to 0.59% ppm, gram per ton. But whereas the recovery, we are getting 70 to 93.4. So it is not the grade of the ore. If you see, the grade of the ore of high grade is yielding low recovery percentage because it depends on the nature of association of the ore and the characteristic of that ore. Then we need to assess tungsten, silver, lead, zinc in gold ore also. Because while you are before going for cyanidation process, because cyanidation is the only process available today in commercial we are exploiting, we need to look for these and pre-concentrate and separate all these valuable minerals to recover from the gold ore also. Yeah, so this is a very typical standardized gold process proceeds. So wherever, for crushing and grinding, then we go for cyanidation, then carbon in pulp. Also, if there is a free gold and in a very coarser size, we can pre-concentrate and it can directly go to the smelter. So there is a gravity separation technique after milling, so it can go there. So then copper ore, I will just I described that how you see the present feed ore of copper is around 0.81%, but also from exploration sample we have studied, we can beneficiate 0.2 to 0.4, and we have got the recovery of 20 to 25% grade with 70% recovery. And one of the example I have given here, tungsten and tin is associated with the copper ore. So in the copper concentrate, we have pre-concentrated tin and tungsten. So these also can be excavated from the copper ore. So these are the takeaways. Then lead zinc ore from central India, you see 1.1% zinc, we have achieved 57%. And the interesting thing is here the grinding is very coarse. In the 70% of coarse grinding, we are doing flotation and we have achieved 90% recovery with weight yield of 1.7. So you can see how many thing can do if proper study is done, proper R&D is done. So this is the schematic, crushing, grinding followed by flotation. You can see the zinc concentrate and the final tails. So almost all the zinc we have recovered. So then rock phosphate. India is importing 80%, around 80% rock phosphate for fertilizer use from abroad. So we are draining a lot of foreign exchange. Here you can see from Rajasthan, we have done some subgrade ores, then some plant tailing, process plant tailings, and we have achieved the desirable grade for fertilizer industry. And the company RSML is going to implement the process also. So the suitable process route we have developed, then concentrate produce are suitable for fertilizer industry, and the huge quantity of tailing can be utilized. So these are waste utilization things. Then I will come to the main focus of this meet and workshop is iron ore. So my previous speaker spoke about difficulty. Actually, we have done in IBM around last 20 years, 250 investigations of all type of aluminas, all type of siliceous, all type of BHG and BHQ. So very interesting results. So all results are encouraging. Simple process flowsheet we have developed. I will show you two typical flowsheet. This is for low grade high alumina. You can see the 52.92 is the feed, the grade, and the alumina and UI is 8%, 72 and 6.45. So around 16% impurities are there in chemical assay. But mineralogically, it is hematite with clay and gibbsite. So both clay and gibbsite we could recover, and we could achieve the grade of 64.3 with around 5% silica plus alumina model and 41.9% recovery. So this is a simple flow sheet. I will show you only two-stage hydrocycloning and gravity. So the Indian iron ores are amenable. So we should go ahead. The time has come. We should go ahead. Then we'll give you some BHQ example. We can see 48.17 silica. So the total impurities contributed by quartz. Here also we have achieved it, and the weight yield is around 27%. This is a very recent study from Central India, and this is the flow sheet. Here you can see hydrocyclone, then gravity. So we are magnetic we have done, but simply if you are achieving with the simple flow sheet, what is the need? There is no need to go for complicated. So this is cost effective, efficient process, and viable for industry. You can see the main thing of this flow sheet is we can reject the coarser material. If you reject the coarser material, so why to load the mill? Then why to generate more slimes? So here 20% by weight we have rejected by jigging. You can see the process, and here you see the product. So these are all. This is also pilot scale we have completed. So then low grade iron ores. So as I explained, that we have studied 250 investigations. So you see we have divided into three parts. You can see the grade, the feed grade, the concentrate, and the weight yield. So these are all very cost effective and efficient process. So we should go for beneficiation followed by agglomeration. So these are the major advantages. If you do the physical beneficiation, suitable sinter and pellet grade concentrate you can get. Fines, there are a lot of fines available in the old tailing ponds. So there is no need to grind all those fines. Those can be utilized. Then low lumpy BHQ, BHJ ores also requires grinding. That is the difference between the old tailings and the present hard ores. If you use pellet, it increases the productivity of the blast furnace. If you see the steel policy with the present requirement of steel industry, so you need to reduce the burden on the blast furnace. If you reduce, then you have to increase the sinter and pellet use in the blast furnace. So if you want to increase the sinter and pellet, then you need to do beneficiation. So beneficiation is the need of the hour, and physical beneficiation has the problem solving issues associated with this, so we can do it. Then reduce the burden on storing the tailings. If you do the beneficiation, you can reduce the tailing also. The tailing burden will also be less in the tailing pond or in the storing the rejects. So these are the practice followed so far. Why there is a lot of slimes and tailings are pending? Because we have not adopted the beneficiation. We are only doing the washings. We are only sizing to feed the material only -40 plus 10 mm or -18 plus 6 mm to the steel plants. Because a lot of high grade ores are available, so we are doing that. So just I will take 2 minutes, I will finish it. So another way forward is actually all the process plants should engage process engineers, because all the process plants are actually run by mechanical engineers. So if a process engineer will be there, he can check and see what are the problem we are facing, whether the process is correct or not, process is running in the proper manner or not. So the pellet plant should come in a big way, because when there will be beneficiation, we need a big way the pelletization. So my suggestion, we should use energy efficient equipments, then transportation of ground products in a solid form. Then another suggestion is we can use alumina rich tailings, process tailings in cement industry also. Then process reject of BHQ and BMQ can also be used in high silica foundry, abrasive, stowing purpose, and M sand, the manufactured sand. There is no need to go for M sand. So these are alternative use of our plant reject after beneficiation. Then dry disposal, then backfilling of the coarser rejects. So these are the way forward for adopting beneficiation in iron ore industry. So these are the new policy regimes. Actually, how beneficiation came into picture or into more focus, because the amendment of MMDR Act made mandatory units auctioning of mineral blocks. When auction will be there, then there is a requirement of exploration, detailed exploration. When detailed exploration will be there, then beneficiation is required. Without that, how the price of the reserve price of the block will be fixed. So that is how actually in the new regime after 2015, it has gained momentum. Then National Mineral Exploration Policy focused on beneficiation. Then National Steel Policy is already there. The new policy regime says that sustainable mining practices, resource conservation, mining waste generation, and efficient beneficiation practices. So the National Mineral Policy already emphasized the lays down the framework for exploration, extraction, and beneficiation of minerals in India. So for that, value addition, encouragement in the beneficiation, then highlights the need of the research and development. So these are the policy initiatives because Make in India initiatives there. Earlier there was very few equipment manufacturer in India. Now they have increased. There are a lot of equipment manufacturer, not only lab scale, in the pilot scale also, commercial scale also. So we should make use of our own indigenous equipments and indigenous technology. So for utilization, the suggestion is the policy should link with the mining leases with the beneficiation obligations. Unless only there will be some linkage with the mining lease, then nobody will do the beneficiation just only to exploit the high-grade ores. Then support for R&D and innovative technologies, then incentives. So these are the suggestions. Some key aspects, so if you do beneficiation, so there will be resource extraction, resource waste generation will be reduced, import overall resource efficiency will be enhanced, then we can align with the sustainability goals. So economic development will be there, downstream industry will come up, then generate employment will be there, then export and trade, there will be more international collaboration, and there will be high value product, export of high value product and finished products. So thank you all. Thank you for listening.
We'll take it later. All at once.
Yeah, good morning. Thanks to Metro, I could reach this place. And if I have not reached, maybe we are all on time. Is it loaded? Yes. What I'm going to talk about this morning is that what are our challenges and processes. I have just one slide about the institution that I come from. I've been with it for the last 25 years, shaping it. How do we define science and technology? We ask students sometimes in interviews. Science is knowledge creation. It happens at the interface of domains. Technology is knowledge integration. You have to integrate many, many areas to get to technology. So in my place, we have three verticals: advanced materials, design and manufacturing of components and systems, and electronics and control. This is the minimum 3 genes that you would require. So what I would like to talk about in the next 15 minutes, if I'm allowed, you can stop me. I've arranged it in such a way that I can stop with a case study or example wherever we are. Nature is operated on a high pressure, high temperature processes. And with years of weathering and other processes, we got the minerals. This is what nature is. Now we are trying to reverse it. So we are only limited to the processes again that nature gives us. And we have wasted a lot of resources. Now we make products out of this and we disperse it. The entropy is increased. And again, we try to take it back in waste to wealth or urban mining. So in other words, we need a more systems approach. Sorry. So what's the challenge? The challenge is basically, I can summarize it in 2 words. Our challenge is we have to put in more energy, we have to put in more chemicals as we go forward. Why? Because we are going to get leaner and secondary sources. Therefore, we have to go for finer grinding. We're going to use more chemicals. And we'll also, the grade is less, so we're going to produce more tailings or residue per ton. This is the challenge. And the water stress is going to be very high. And therefore, we have to engineer urban mines as well. I'm not talking just urban mining of waste to wealth. The difference between secondaries is that it comes concentrated in one place. But once it is a product, like our plasma screen or a mobile phone, it is highly dispersed. So we have to create a deliberate urban mine. as a policy. Now, I'll take a bird's view. What do we need? I said we need a systems perspective, which is a bird's view. And the individual competences, I would take it as a worm's view. In other words, take a bigger problem, do attribute mapping of what we need. And then you have to do both top down and bottoms up concurrently and develop hierarchical structures. Do the energetics. In physics, you would have learned the quanta of energy, its length scale on which the energy operates, and the time constant it operates. If you look at it, between a galaxy and inside an atom, the laws are the same. This trifecta determines everything. Pattern recognition, network analysis of data. This is what is common to all systems. Now, let me tell you in brief, and these are all called maps. You see this is a PNT map, pressure temperature map. This is how nature has operated. And what we see in the center around room temperature and 1 atmosphere is the reactor of the planet. So the size of the system will be very big. I can even make it bigger as the size of a universe, stars also. But if you move away from these 1 atmosphere and room temperature operations, the energy input and the material input goes up. And the size of the reactor, costs of the reactor goes up. As you go up high temperatures, you can't create high temperatures up to 10,000 Kelvin beyond a plasma. You go to high vacuum, you can do steel refining a little bit. If you go to high pressures, okay, you have hot ice. No, these reactor sizes start becoming smaller as you go away. You go to the topmost right, you'll see the star, which we are creating as a fusion reactor on Earth. So what is the sum and substance of this slide is that these, if we know the pressure, temperature, field, and strain, and these kind of variables, they are independent of size. You can have small reactor as well as the star level or a planet level reactor. Now, if you look at it, if you add to pressure, temperature, you add a field also, electric field, magnetic field, dielectric, sonication, you got a 3-dimensional processing space. We actually do that, right? We do magnetic fields, we do electric fields. It's easy to create an electric field, but it's much more difficult to create large magnetic fields in large spaces. So this is what it is, but nature would have already done it. You see, liquefaction of gases is done, we take methane, hydrogen, liquefy it at low temperatures and high pressures. But in Jupiter, it will naturally happen. Yes. So like that, we can process in space. This is the philosophy of materials processing. We'll come to the second part. Now, take this philosophy and see how I can apply it now for innovation. Now, the knowledge that we have across many, many domains, we'll call them as micro knowledge domain. That's what you come with a specialization. My friend here will come with beneficiation. Somebody will come with solvent extraction. Another person will be with surface engineering, whatever it is. Then we have process methods as well as the mechanisms by which they work. We cross-fertilize the process space in a design format. We create complexity. That is how nature works. If you take that, you get, see, whatever nature does, if you follow it, you will not go wrong. In biology, you would have learned differentiation, selection, which is satisfying a fitness function, and that which satisfies multiplies. This is used in product development also. Same thing we have to use in process developments. We have, as I told you, you have all the micro knowledge domains. Now you have to put a fitness function and see which combinations will work. This is a universal theorem. These slides are written. Therefore, if you take an overall view, a systems view, you have to use chemical systems, but bleaching, flotation, surface chemistries, electromagnetics. You have to develop process equipments, that's what we are poor at. Then mechanical forces, fracture mechanics, how you break things, pattern recognition. So the whole lot of these things is seen together in total. Each of these things will have hundreds of fields, micro domains. Imagine combining them and we get it like a hit. So how does the innovation space work? I give you 5 examples. If you are doing crushing, grinding, anything that moves is done by a motor. Without a motor, you cannot do anything. Everything that moves is motor. Energy efficient motors and VFD drives will reduce energy consumption by 30%. We have to engineer slags now, and we have to start using new solvents like liquefied carbon dioxide, liquefied ammonia, etc., which will start working in reactor spaces. But more importantly, we need hybrid process. We have to combine energy and chemicals. We can reduce chemicals. We don't mind increasing energy a little bit, but we have to reduce the chemicals because we can start producing energy from renewables as we go down. Then we have what we call as, can we use blasting, which is the energy-wise very efficient, but it is very dispersive. But can we do it and bring it to smaller and smaller sizes like a microblast and start making it finer and finer as before you take it up into your crushing grinding circuit? That's an area where, then of course, the last one is two very well known, pattern recognition and rapid sorting. Sorry, I did something. Yeah, I want to tell you examples. I'll take it now. We have to deal with, let us say, I can take a couple of them. Take secondaries, lean ores, or high purity silicon, or whatever you want to produce, rare earths. It'll take a long time to go through all of them, but if I take one or two to finish off my talk, an example, I don't know, I'm not moving here. Can you just move it? Yep. I want to give you one small unpleasant or a pleasant truth. We ask the students this, we teach them, but they still don't. There are only two reductants available to you for metallurgists. One of them is carbon, other is hydrogen. And even hydrogen, it can be produced from carbon, which is thermal, or from renewable, which is green hydrogen, gray hydrogen, blue hydrogen today. Both at the fundamental level, it is electrons. That's it. That's all the reductant you have. From that, we get sodium, calcium, which is, and aluminum from electrolysis. And from that, you get magnesium, even by electrolysis, then silicon, then lanthanum. So calcium and lanthanum give you rare earth. Electrolysis gives you rare earth. So that's all you have. Your set is only this. It's very, very, very minimal. So here, I'll give you one small example, two examples I'll give you. If you go for a low grade gold ore, which is called a refractory ore, it will even contain 4 ppm, but people have kept it away because it is more difficult to process. Or you take a dump, which is a process dump. It is not a tailing dump. We have written it as tailing dump. It's a process dump. So what we found out interestingly is that if you analyze for the gold in normal way, we get about 0.7 ppm or 7.7 grams per ton. But if you are able to go deeper with high resolution systems and find out anything else is there along with it, we were very pleasantly surprised to find palladium and rhodium. And we have to prove it. Right? So we took tons and tons, 10 tons and whatnot. So why does it happen? We found out that gold occurs naturally, right? That's why you put a cyanide, it comes out. Gold does not form a compound. So it sits in the interstitial space between the grains. That is what has been leached out easily, free gold, from British times. Imagine they had 45 ppm and all that, 45 grams per. So trillions of pounds worth of gold has been taken away. Now we are left with 1 ppm, stuff like that. Now, if you look at it, the green ones have been easily taken away. And then you have the yellow one, which is inside the sulfide, which is called the refractory ore, which is still available in many, many places, which is not even mined. And third one is red, which is embedded, which is nanoparticles, 10 nanometers to 100 nanometers. Now, can you take these things out? Now, the easy one to take out is gold at the interface. Cyanide will put it, you take it out. The next one, little difficult, yellow one, that you can take it out with a hypochloride ion or something. But once that is locked up, you need a chemical scissor. You can't dissolve millions of tons to get a ton. You can't throw acids. So you can't dissolve the particles. Without dissolving the particles, you have to take it out. So you need a scissor as a solution. All right, I go there or, okay. So we started looking at cyanide-free process. These are established ones across the world, from low pH to high pH. And one of our innovations is to combine them. Imagine if you are having 4 steps in a process, and each step you do 90% efficiency also. At the end of it, it will be 60%, 63. Table 9 is very ruthless. 9, 0.81, 0.72, 0.63, 0.54. So the more the process steps, even if you are at 90%, you're going to have a problem. So we found out a solution finally. If you do only standardization, whatever is a free gold that is left, any process that you take, even 2 ppm, 3 ppm gold, you leave 0.5 ppm down. The next one is if you use in situ oxychloride circuits, you can get the yellow ones out, you can see. And we added one more reactant without dissolving the whole particle. And the nice thing is if it is a tailing, it is already at 50 micron or particle size, you don't have to crush and grain. So you could get it out. So this is the example. And what is important here to see is that the process technology should be able to simultaneously take out all the three. The reagents that you use or combinations that you use, if you find other things like palladium, rhodium, which we found, you have to take it out. And not only that, we need to look at what do we do. Again, we are taking only ppms out of it. We are taking 1 or 2 grams out of a ton. So 30 million tons will remain as 30 million tons. It will not reduce. So we need to find other products as well. The process should be scalable. It should not have the water stress. And hopefully we go for a zero discharge. So we came up with a configuration for the plant of 1 million tons. The mistake that is always done is people take dozers, conveyor belts and start moving the dump. That's wrong. You don't do like that. You have to have only move a concentrated material, not a 1 million ton material. So you have to create ponds and you use the residue and the pond itself as a liner and not create reactors with steel or FRP or anything. If required, you can. And you need a portable boom type of agitators. In other words, the plant becomes portable. So with this innovation idea, we can go to 1 million ton at 4,000 tons per day. There are 10 dumps, even if you put 1 lakh per year per dump. Then once you have dissolved it, digested the gold out and then take it out and then strip it out, it becomes concentrated. You are in GPL levels now. Then that solution only you take it to a central plant and operate. So this is an example of how. Now I'll give you another example in just a minute, which is a bit. Okay then. So the point is, I just finished it verbally. If you take silicon, there is only one process called the Siemens process. The Siemens process is a trischlorosilane process. Very costly, very expensive, very. Now how do we solve the problem? Can we come up with a simpler process starting with the metallurgical? You can do it because only boron and phosphorus you have to reduce. So if you go for quartzite or metallurgical grade silicon and try to remove boron and phosphorus, you can produce the metallurgical grade silicon at a much lower cost. So this is the sum and substance slide, last slide.
Hello, my name is Professor Dr. Das Gupta. Actually, I think we were just talking the how to increase the utilization of the fines in iron ore mining. You see, I'm talking of the construction projects like roads and dams, and where we use a huge amount of the sand of -6 millimeter size. And this sand naturally and the manufactured sand. And there's there's a huge shortage of the sand and the cost is rising day by day of the sand. So in any concrete making, the consumption of sand is around 30%. So have you made any studies, the use of these fines as a sand material in construction projects?
Yeah, sir, that is a suggestion I have given. So that is a substitute for M sand. When after taking out all the valuables, if suppose you can use the pure silica in glass industry, the grade 3 glass industry, in foundry, those will fetch more price. So once all those things are there, then the remaining portion can be used for the M sand purpose, which is has no value for other industry, then can be used. Otherwise directly also can be used. So for construction purpose, we have not connected, but our suggestion is it can be utilized because now these are all exploration studies and exploration samples. Once the mines come up or the plant come up with for utilizing this BHQ ore, then simultaneously, because we need large quantity of ore to study for this how it will work. And the user, suppose for M sand, you can give the specifications for your purpose, for any industry purpose, or whosoever is requiring the MSAT, then also we can suggest and we can carry out the study. There is no issue.
So these specifications of these fines must be included in the specification of sand as per the bill of material, you know.
Yes, sir.
Yeah.
So
So I think how to propagate the use of these
So if
fines
you-
so
if
that
you-
the fines can be utilized, and there is a huge demand of the sand in the.
Yes, absolutely.
So
That-
this is very important.
Yes, it can be, sir. It can be. So if you only give the size specification, we can suggest. There is nothing else. Only size specification, whatever your MSAN you are producing, if you give, then it can be used, sir. Absolutely. Because to process this ore, we are going to 100 mesh grinding. So if whether crusher rejects, minus 6 plus 5, 10 mesh will be useful, or minus 100 100 mesh will be useful. That need to be seen. Otherwise, there is.
It's basically about minus to 75 to 80%, minus 75 microns.
But that can be placed very well. No issue.
Thank
sir.
you.
Any other questions? Yeah, please.
I am GK Pradhan. About the sand part, I am telling you, Western Coalfields and Northern Coalfields, they did a wonderful job. They crushed all the waste coming out of the coal mining, and they are already marketable in Nagpur and other places. This is an information we are, from mining side also, we are going for substituting sand in a big way.
Okay, thank
This
you.
is an information only.
Thank you. Any other question? Otherwise, we'll take a break. Sure, please. Last question.
You are talking about the sulfidic grade of gold ore. So sulfide means the refractory grade you are talking about. Any solution is there for
No,
processing?
they're
of
both. That's what I showed you in the last slide. All the three parts of the gold are taken. Free, easy gold, cyanide has already taken it. The sulfidic part of it is OCl minus and Cl minus. Combination of chloride, hypochlorite, halogen processes have come which have reached pilot scales and pre-commercial scales already in Australia as well as in Africa. Apart from that, you add one more reagent which solution is there. We have done it up to 30-40 tons of studies. We have actually moved the dumps to this thing. So both dumps, tailings as well as refractory ores can now be handled without a problem with a non-cyanide process, which is now environmentally green. It is available. Yes, the technology is, we can also give.
Thank you, sir.
We will close this session here. We are expecting mining secretary very soon. I would like to thank each and every speaker for being on time. And I think the discussions today were quite impactful, and we will create a proceeding out of it. And now I would request Professor B.K. Mishra to kindly hand over a small token of appreciation to all the speakers. Ladies and gentlemen, we'll just break for 5 minutes. I'll request you to have your tea and coffee and soon join us soon. Thank you. Good morning, ladies and gentlemen. We are really honored to have our chief guest with us, Shri Vivek Bharadwaj, Honorable Secretary, Ministry of Mines, Government of India. We will start the session right away. I would request Mr. Abudhay Jindal, Vice President, Indian Chamber of Commerce, to kindly join us. Mr. S.K. Chaurasia from NMDC to kindly join us. And Mr. A.K. Mukherjee from Tata Steel. I would also request Mr. B.K. Mishra and Mr. P.K. Satija to kindly join the dais. Dr. Mohan Yalishetty will join us online from Australia. The session will be moderated by Professor B.K. Mishra. And now I would request Mr. Abudhay Jindal, Vice President ICC, for his opening remarks.
Good morning. It is an honor for me to welcome all the speakers on the occasion of 12th India Minerals and Metals Forum organized by India Chamber of Commerce. We are organizing this forum in association with Ministry of Mines, Government of India. On behalf of ICC, I would like to welcome and sincerely also apologize to our chief guest, Shri Mr. Vivek Bharadwaj, Secretary, Ministry of Mines. I would also like to welcome Ms. Roopwant Singh, IAS, Managing Director, Gujarat Mineral Development Corporation, Mr. Avitav Mukherjee, Chairman, NMDC, Mr. Sandesh Nayak, Managing Director, Rajasthan State Mines and Minerals, and Professor B.K. Mishra, Director, IIT Goa, and Dr. Mohan Yalishetty, PhD Associate Professor in Resource Engineering, Monash University, Australia. Mining is a crucial activity for the Indian industry and economy. With more than 3,500 mining leases for 40 major minerals, covering a total lease area of over 3 lakh hectares, India is a major producer of important minerals. Mining as an activity has the potential to impact environmental sustainability, social inclusion, and economic development. The mining of rare earth metals, considering their importance in renewable energy and clean storage technologies, is also expected to increase significantly for achieving reduction in carbon dioxide emissions. In this scenario of rapid consumption of mineral resource, the sector needs incentives from the government for beneficiation of low grade of iron ore. To reiterate the point made by industry bodies, beneficiation should be made mandatory for non-saleable ores below 55% grade as per business requirements. At the present rate of consumption, the existing reserves of high-grade ores may not last beyond 25 to 30 years. Hence, to meet the future requirements of iron ore, we need to utilize additional resources like BHQ, BHJ, and low and lean grades, which are in abundance in our country. As we all know, the process of beneficiation involves separation of economically essential minerals from their respective ores. Only the ores with high percentage of minerals are beneficiated, as they provide the best output. On the other hand, ores with lesser concentration of minerals give very little output. The process results in high production volume in less time, thereby increasing the metal content of the ore, decreasing the gangue content, and getting the most out of the material. The scheme of mineral beneficiation was developed for processing of high-grade ores through targeted utilization of lump and fines. But given the increasing demand of high grade of iron ore for steel making, there is a need for lower alumina content of ores to a specific level. Controlling the alumina content in the charge of the blast furnace, coupled with the complexity of the beneficiation of Indian iron ores, considerable R&D efforts have been made at National Metallurgical Laboratory to develop a suitable process for meeting these twin requirements. In order to address issues related to environmental pollution while also conserving and maximizing resources, the need of the hour is the complete processing of iron ore lumps, fines, and slimes. The fact that the country's natural resources are located in the forest cover areas raises further environmental and social economic concerns. As one of the fastest growing economies of the world, there is an increased pressure for metal and minerals to meet the demands of an estimated 6% growth in GDP in the following decades. India's commitment to the Paris Agreement entails the requirement of crucial minerals for the transition to a lower carbon economy. The Make in India initiative for expansion of industrial sector will further increase demand for mineral resources. Considering the increasing demand of quality iron ore and limitations of current beneficiation circuits, there is a need to adopt improved technology for beneficiation of low-grade ores, as we have discussed earlier. I will conclude by saying that the iron and steel industry has been on the forefront of finding solutions to all the challenges that have emerged in the past. This is the reason why industry occupies a pride of place in the global arena. With the intent and technology supplied by industry, and incentive and support extended by our government, I am confident that industry will set benchmarks for all our global peers to emulate. Thank you, everybody. Jai Hind.
Thank you very much. Once again, I'm B.K. Mishra. I'll request Dr. Mohan Yalishetty. He will be speaking to us from Australia. Anyone would like to bring him in? He's on. I think this is. Yeah, I think we see his slides. Are these his slides? Okay. So.
Yes, I'm here.
Sure. Go ahead, please. Thank you very much.
Yeah. Namaskar to everyone. And Mr. Jindal, the chair of the session, and my special mentions to Shri Vivek Bharadwaj, IAS, the Secretary, Ministry of Mines. I also want to congratulate Mr. Bharadwaj for bringing out an excellent volume of first ever India's critical minerals list. Thank you for that extraordinary work by you and your team at the Ministry of Mines. Also, I would like to acknowledge the presence of Professor B.K. Mishra, whom I had long association with, and currently he's at Goa, IIT Goa. And my long-term friend, Shri Rupwant Singh, again, Commissioner of Gujarat Mineral Development Corporation. And rest everyone, namaskar. So again, thank you very much for this fantastic opportunity to be among some of the luminaries of Indian minerals industry, and including some of the other important stakeholders, the ministries and different geology departments of the state governments. So as I said, I'm Mohan Yalishetty. I'm co-convener at the Australia-India Chamber, looking after National Critical Minerals Strategy in Australia. And also I'm a co-founder of Critical Minerals Consortium at Monash University. I'm a passionate mining engineer, as you will realize. Before I get started, I would like to acknowledge and pay my respects to the traditional owners, elders, past, present, and emerging of the lands and waters on which we live and work. That's a customary acknowledgement that we give to the country being in Australia. So my presentation is going to just focus, because given the time limitation of 10 minutes, and I don't want Secretary Saab to wait too long before everyone is eager to listen to his address. So I would touch upon the important mega trends in the mining industry, because what we are talking today, the changes in the minerals processing or mineral beneficiation, they are underpinned by some very key and important trends that happens in the mining industry. And I have been associated with mining and minerals industry for over 3 decades now. So I have seen how the industry has grown from strength to strength. And then I will come back to a bit of mineral processing, what it exactly entails, and then some of the global trends and underpinning reasons why we do what we do, and then how Mr. Jindal touched upon briefly the critical minerals, a new story. Because when I went to mining school, this story was never told or never discussed. That's over 3 decades. But as Secretary would emphasize, the critical minerals are bread and butter of, kind of everything that we do, modern technology, including the way that I'm able to join in this particular conference, thanks to critical minerals and the emerging technologies. First thing first. So as I said, the minerals underpin everything we do, whether it is from a simple laptop device to the high-end electronics and the strategic equipment that goes into defense and shaping the future of the country. So they underpin pretty much everything. And what's happening? The growth trajectories, if you look at, is exponentially growing in most commodities, including critical raw materials, because they are fundamental determinants of human progress. Whether you talk of constructing buildings, constructing roads, constructing, the new gigafactories, everything we do today have something to do with minerals. And I also want to touch upon some of the important transitions that we have seen, at least in my own 30 years career in the minerals industry. I've seen this grow, this happening. For example, the grades have become very leaner. That's exactly was one of the discussions in the last session that I was listening in. So high grades have become low grades. For example, in fact, when I met Honorable Secretary in Sydney when he came to attend IMARC, one of the things that he was alluding to was the Kolar gold fields and how the historical gold tailings contain higher grade compared to the grades of the ores that we get in a kind of greenfield projects today. So that's one of the important things, as you can see, declining ore grades. And then simple mineralogy to very complex mineralogy. And the shallow lying deposits are almost over. Now we are getting deeper and deeper with our mines. And the cost of production pressures are increasingly upon us, where cost of producing has gone up. And the waste, if you look at the mine waste, which means when the grades have become leaner, that means something else has compensated that for the ore. So which means either it is the gangue minerals or the waste rock. So that that's an important transition that we are witnessing today. But one thing, all arts, but what is that that is working in favor of the minerals industry, in our favor, is the efficiencies at which we work, the scale of efficiencies. For example, when you talk of the previously discarded tailings, now it is, as you would realize, most of you would realize that it is very rare to find some of the high-grade zinc deposits not being found too often. And if you look at some of the old tailings of zinc smelters and refineries, and even zinc tailings are now being considered as the ore bodies of the future. So that has been a reality, a stark reality of our times. What exactly happens? So minerals processing operations generally follow a specific set of unit operations or unit processes that we all are familiar with. So for example, here is what I'm giving. Copper, when I was at the university studying mining engineering about 32 years ago, so the copper grades were about 2.5 and above. But today, we are grappling with copper grades of 0.6. So what exactly we do is, through beneficiation or minerals processing, we upgrade that to, say, 25%. And then by the time it goes through the smelting and refining, we are getting to 99.9 purity of copper. And the same thing happens to gold, 0.8 grams per ton of gold. Again, at the time when I was studying mining, was a waste. And the same thing applies to when I was working in Goa. So we used to produce lumpy high-grade iron ore versus very fine iron ore grades, fine material. Fine material was discarded for so long until the China came as a market. So, but when Japanese were the main buyers of Goan iron ore, they were mainly, their specifications were very clear and crystal clear, saying that we need only lumpy iron ore for that reason. And what happens? So when you're talking of only 1% of copper, just 98 to 99% is the rock mass, which has to go into tailings dams. So that means the waste volumes are growing hugely high and high with as the time progresses. So then again, I just wanted to bring, again, most of you are familiar, but just to recapture some of our thinking, our understanding. So if you look at the abundance of different elements in the mineral deposits, if you look at, these are an average grades of the ores that we get worldwide. If you look at aluminum, about 8% crustal concentration, but typical ore deposits contain about 30%. That means you will have to have an enrichment factor of 4 to be able to convert that into 100% alumina, for example. And same with, there are some of these traditional metals are less in terms of the waste volumes, but compared to the base metals and precious metals like such as gold and copper and so on. So the diagram below explains the typical unit operations or processes that we generally deal with when it comes to the minerals processing operations. So you have got run of mine ore that goes into a bit of comminution circuit, which includes crushing and grinding, and which is one of the highly energy intensive operations, as we would appreciate. And that's where now countries and companies and the corporations and organizations are now trying to reduce their energy footprint, not only because they want to reduce the cost of production, but also the climate change concerns. And not enough renewable energy is currently being deployed at mine sites for their use in all these processes. So if you look at the just mining value chain, about 80% of the energy consumption happens in that crushing and grinding, which is a big ticket item. So that's where some of the changes are warranted. So when we think of any change, so change can be incremental or gradual, or it could be a step change where significant benefits could be achieved, or it could be a disruptive change. So that's where the future, when we are talking of in today's conference, where we are trying to understand global trends in mineral beneficiation, that's where companies like BHP or Rio Tintos or Vales, all these big multinational giants, with whom many of Indian companies, for example, Vedanta or Birla Group, or all these have to sort of tackle with. So there are several factors, as I alluded to, that are playing a role in influencing the trends in mineral beneficiation processes. So they are either underpinned by the market dynamics, the price fluctuations, because commodity prices are known to be very notoriously fluctuating, because, and again, as an August gathering of this nature, people have an appreciation that how countries and the companies were vulnerable of the rare earth prices, and also most critical minerals, critical raw materials. And of course, technological advancements, as I said, that's one of the very positive on our side. That's how those step changes are happening within the industry, which is able to come up to some of these challenges thrown at it. And again, environmental, social, and governance considerations. So regulations are getting stricter and stricter. I was told by my friends in Goa, I left Goa in 2006. And soon after, I think within a few years after that, the entire mining has come to a standstill. So again, it is compelled by certain social obligations and environmental regulations that have been brought into force. So that we need to do our business in a manner that is sustainable, that is collegial with everything that we work in whatever environment. And collaboration and knowledge sharing and value addition and diversification. This is where I'm more passionate about, because traditionally when I studied mining, again, we were talking of, if your main commodity of interest is iron ore, we would only bother about iron ore. We would only bother about iron, but we would discard everything else. But increasingly now there's awareness, because already you have crushed and ground to a very finest constituent all these, and then liberation and separation becomes much easier by an extra marginal spending. That's where many companies are adding additional circuits. For example, if you're talking of Olympic Dam in Australia, which is mainly copper, gold, uranium kind of deposit, now increasingly they are looking at extracting tellurium, because tellurium, if you look at 98% of the tellurium worldwide is sourced out of copper slimes. So that way you can monetize or valorize some of your waste streams, which was one of the discussion points in the previous talks. So people are able to do that. And same thing, if you look at Quebec, Rio Tinto is able to separate selenium and also scandium, which goes into aluminum alloy making, wherein lighter aluminum becomes stronger like steel. So those are some of the avenues where companies are trying to monetize the waste by extracting the byproduct metals. Already, the blasting has been done, the crushing has been done, the grinding has been done. So that means only with additional marginal spending, you are able to achieve great value out of the same material. And this is one of the recent papers that I co-authored with Professor Robin Batterham, who was former chief scientist of Australia. So wherein we said that, okay, now we are talking of in situ leaching as a means where minerals are extracted or metals are extracted, which is popular. For example, if you look at uranium as a classic case, about world's 50 to 60% of uranium today, as of today, is extracted through in situ leaching. And same with copper, rhenium, and gold, and a number of other, including some of the rare earths are being tried out at a kind of pilot scale. So what we said is, now one of the important underpinning, important characteristic that you need to have to be able to separate metal from its mineral is the liberation. So the crushing and grinding that has to happen, because when you talked in my first slide, I said several important transitions. One of the transition is simple to complex mineralogy. Now, minerals are going from oxide to sulfides, and also, but at the same time, grain size. If you look at fine grain to coarse grain, and coarse grain means you have to grind it more finer. So that means you'll have to spend more energy. So what we said is, already you got plenty in Australia. In fact, Geoscience Australia spearheaded a project called Exploring for the Future program, in which they assessed what is the potential sitting in these tailings dams in terms of recovery of critical minerals. So, but we have gone further and said, okay, can in situ leaching be an option where we recover some of the valuable metals out of these tailings that are sitting there in perpetuity? One, they are causing a lot of harm to the environment. Two, they are an environmental nuisance. In fact, one of the speakers in the previous session said, whether we could find alternative uses to tailings, whether it is green cement and so on and so forth. So for that reason, this paper talks about a special compound called slow releasing materials agent, which is again a patented item at Monash University, where I work. One of my colleagues, Professor Ranjit Patagama, my PhD supervisor, and his team has produced. So that would be a kind of, it would facilitate the leaching solution to percolate through pore spaces and release the metals. And finally, would be my final slide before I come to conclusion. So in the past, we only talked about the mainstream metals, but today the metals that lie in the subsequent circles, they present great potential for us to be able to recover some of these important key materials. And again, we are able to have the presence of Honorable Secretary, from whom we are going to hear the policy that was unveiled with respect to critical mineral strategy is concerned. So if you look at, let me just quote one particular example. When you're talking of aluminum, where is aluminum in this? So for example, gallium is one important metal which is currently sourced 100% from red mud. So that way, as you go from inner to outer circles, so that's about 25% of these outer circle metals. Sorry, these are the mainstream metals, but the next circle is about 25% dependency, 75 and 100% dependency. So as you go out in the outer circles, these are the companion metals where the recovery could be very useful. And why they are important, if you look at this classic chart, 1980s, about 11 elements made a typical printed circuit board, a PCB. By the turn of 1990s, you added 4 more elements. And by 2000, it is a combination of 45 metals. So metal intensity of most of our components have gone up because, again, you need precision, you need low energy consumption, and so on and so forth. These are some of our desires. So to be able to meet those desires, we need metals that underpin these technologies. I think that's kind of wrap up. Given the 10 minutes time, I've exceeded, I know, my apologies. So again, market dynamics and shifts in global demand for specific metals have surely influenced the beneficiation trends. So energy and then climate change mitigation. And again, other important, for example, Chile, copper is not a critical element, but if you look at about 60% of world's copper comes from Chile, where one of the highest water stressed regions. So availability or non-availability of potable water could be pushing copper into criticality list. So that's where all of these broader thinking is, because again, mineral processing as grades have gone leaner. That means you need more reagents, more water, more energy, and more everything. So that's the final, perhaps, thought that I want to leave you with. And again, thank you so much for giving me this opportunity to share, especially in the presence of Secretary and other very distinguished members from Indian mining fraternity. Thank you so much. Happy to take any questions, but again, it's up to the time that you have left.
Good afternoon, dignitaries in the dais and off the dais. Myself, S.K. Chaurasia, GM R&D, NMDC, and I would like to talk on utilization of low-grade iron ore. Many speakers in the first session also spoke about it, and I will also tell something about, please switch on my presentation, please. Yeah, before my presentation starts, NMDC is mainly working on iron ore, and we also have our own diamond mines also, and we are extending our work in the coal and other mineral side in India and abroad also. And next slide, please. I will speak on these lines about NMDC and various works we have done in our R&D center and how to utilize low-grade iron ore economically. Now, about NMDC, I don't think it is required to tell everybody. I already spoke about NMDC. Now, slurry pipeline and pellet plant. Why I am talking slurry pipeline is because the moment you do beneficiation of low grade, you end up with the concentrate which has to be transported to for utilization in blast furnace by pelletization route only, because size is so low you cannot do sintering. So beneficiation should be clubbed with pellet plant, may not be with the slurry pipeline, but slurry pipeline is good alternative for transportation and cheaper also. So NMDC is putting up, already have beneficiation and pellet plant at Donimalai working, and also we are under construction pellet plant at Nagarnar, where our steel plant also coming, and beneficiation plant at Bacheli in Kirandul area. Now comes to the scenario of iron ore. Already we spoke about what is the grade of Fe. 62% plus Fe is considered to be the good iron ore or best grade iron ore. But what about less than 62? Generally people are doing blending, particularly the miners which has blessed with best iron ore, particularly iron ore of NMDC. We have at Baladila very good iron ore, even sometimes 65, 66 also we are coming. So many times our miners, to remove or utilize that low grade, we are blending and using it. But as a metallurgy point of view, it is not correct, because the moment you are utilizing low grade, in fact you are adding the gang material to the raw material. So your end user or blast furnace operator or DRI operator has to incur more loss on coal as well as flux, and productivity also will come down. Now you can see how many dumps of tailings and low grades are available in our mine site. Around 130 million tons of the low grade, and slimes also approximately 130 million tons. Next, I already spoke how to utilize low grade. Miner's point of view, it is blending, but not correct. But blending is having advantage. No tailing generation. Your all mines waste also going out. But beneficiation is the correct and right use, right choice. But beneficiation needs some investment, capital investment. And also you have to again generate some rejects. How to dispose economically and environment friendly. That is also has to thought of. Then only you have to go for beneficiation. Otherwise, beneficiation will land up in social injustice to the society. Now, for utilization of low grade, one must know what is the liberation of ore from the mineral. Unless you know exact size where the ore is separated or 80% separated, and you go directly from that 80% size reduction and do beneficiation, you will get maximum recovery. Generally, people are doing 2-stage, 3-stage, and to save, they are saying energy cost they are saving in the grinding, but increasing the unit cost, unit operation cost. People are not realizing the unit operation cost also increases. So my suggestion is, why not go for the exact correct characterization where the size separation of ore takes place, or 80% ore reduction. You can see in the pictures, generally low grade ore, if you go directly for 75 microns or 45 microns, definitely 80%, more than 80% separation takes place, and go for the beneficiation. There are many methods available, which is already done by NMDC R&D Center also, which I am going to say. Now you see wet beneficiation. Everybody has spoke right from the morning, wet beneficiation. Nobody has spoke about dry beneficiation, though somebody has told reduction roasting. Reduction roasting followed by magnetic separation in the dry or in any way. But there are many other methods also. In wet process, I have written only 3 major process: jig, spiral, and magnetic separation. And similarly in dry beneficiation, also 3 types I have shown. One type NMDC has, our scientist has developed, dry beneficiation using compressed air. I think it is not widely used it, widely circulated. We have already patented it, and TRL level we developed up to 8. And you see there are 3-4 types which have written wet process. Either you do it in single or in combination of these 3 or 4, you will get the required concentrate of 62.5 plus or 63. But size will be less than 45 microns or around 75 microns. You have to transport through either slurry or you have to put a pellet plant nearby the mine site. But so people are thinking the cost of beneficiation. They should think cost of pelletization also in that. And pelletization also is a big subject. It is not easy. Many times your concentrate cannot be pelletized. There is a big question comes Blaine number. And unless you study properly, your pellet will not be of use to the blast furnace or DRI process. Similarly, for dry beneficiation, there are many methods. We have done a lot of work on dry beneficiation, and which will rule in next decades. Now, some of the process or some of the iron ore, BHJ, BHQ, subgrade, everything we have worked in our NMDC, and mainly that is all wet process. Spiral, we use spiral, magnetic separation or jig, either in 1 or 2 or in combination. We got the required concentrate of 63 approximately, 62.5 plus. So, and this is a specific circuit I have shown, blow sheet, which we used 1 to 6, 1 mm to 6 generally responds jig very well, and 1 to 100 mesh we go for spiral, and less than that magnetic separation. That is simplest flow sheet. If you put it, you will get the required concentrate. You can see we have taken Fe of 51 and we have gone to 64% with a recovery of 74% weight percent. And silica has come down from 26 to 6%. These are the work we have worked for the beneficiation work completed for low grade for various supplier, Tata Steel, Vedanta, Lumita Mines. Many people have worked. It is not a complete list. It is only a simple sample. We worked more than 100 types of ore which we have got it from the various floors. Now for the sale also we worked for many iron ore. Currently 2 days back there was a beneficiation plant inaugurated at SAIL Bhilai. Worked on the beneficiation studies done at R&D Center NMDC. And at present also we are working for the Goa mines under Bokaro Steel Plant of where they are going for capacity enhancement to 12.5 million tons per annum. Sorry. Now ore beneficiation projects for sale, it is in detail. Phase 1 we have completed for the sale. I don't think it is required to tell everybody. Pelletization test work also we have done for many. It is a sample example for some of them. At SAIL, Jindal, Ispat, SAIL Bhilai, BMM Ispat. These are the some of the examples which we have worked. Efforts of NMDC towards dry beneficiation, which I wanted to emphasize. We are working with CISRO Australia also on dry beneficiation. Their reduction roasting also used, and jig also. Air jig is also available, which is working in the dry process. And also we have worked or patented our own dry beneficiation, that is using compressed air. But there are some limitations. It is not that it is applicable for lump or size more than 3 mm. It is working only for fines less than 3 mm. And in the details, I will show you in details in the subsequent slides. You can see a simple charging system. We have done it in our lab, first lab scale. Then this is the picture of pellet scale, which is showing it is working on the principle of gravity. When it is passing through the compressed air and charged fines, the highest density is iron ore, which falls first then subsequently middling and tailing. Tailing or rejects is mainly silica and alumina, which is lighter than iron ore. This is the video of the same. You can see a charging system, a very simple charging system. Though it is a batch process, because lab scale or pilot scale, we are working only in pilot scale to validate our research work or the ideas. You can see first coming out iron ore, dark in nature. Darkest portion is iron ore, then less darkest is middling, and the lightest will come in the last, that is silica and alumina. The salient features of this process is, it is not only for iron ore. It is a process development working for coal also. We have tested coal also. But coal getting higher is your gangue material, silica and alumina. Lighter carbon material is coming in the later stage. So this is not only for coal, this is not only for iron ore, this is working for any types of minerals. But there should be gravity difference. If it is gravity density difference is very, very less, then it is a slightly difficult to operate. Here there are some challenges, because size is one of the challenge. Then dryness, moisture. The moment moisture is more than 2%, it gives erratic report, because moisture makes it globules, and then it is separation takes place difficultly. Now comes how to dispose your tailings eco-friendly. Otherwise, lot of ho-halla will be there. In our mines at Baladila, you might have heard red water issue, because the moment your tailings are there in tailings dam, and the tailings overflow with red water and goes to some water body, and people staying nearby that water body makes halla that water we are getting is not correct. It is highly iron material. So how to dispose it economically and environment friendly? We also done cake out of this tailings and disposed in some good area where there will not be any environmental issues. And also we have seen our work that 20% moisture tailings also can be disposed as a cake. Now, how to utilize for some other purpose this waste? We have made bricks, we made pavement blocks, we made some pigments also out of this waste. That is one example. We are also working with IMT Bhubaneswar. Recently MOU has signed to make some building material out of waste, overburden mainly. Overburden is also a mines waste, is having lot of Fe content, around 35%. Now challenges and constraints in beneficiation. Beneficiation plants are capital intensive. It is not only for beneficiation. You have to think for pelletization, or you have to send your concentrate to some of the pelletization plant. Bhilai steel plant, which beneficiation they have started recently, they are sending this concentrate to third party or outsource to a pelletization unit, and then that pellet they are going to use in their blast furnace. Lower recovery of beneficiation. Definitely this is a drawback, but at the cost of steel making. Less steel making cost you have to beneficiate. Otherwise your downstream, like other steel plants which don't have that good quality, they are incurring lot of cost on the front of coal and in the front of flux and low productivity. Then beneficiation generates waste. I already told you have to think before disposal. Beneficiation concentrate can be dispatched via slurry pipeline or making pellets in pellet plant in mine site. This is the need. You only do beneficiation, it is a useless thing. You cannot send it to the sinter plant. Sinter plant will reject your beneficiated ore because of size. Otherwise their sintering operation will be very poor. Lot of dust will go inside the sintering, and it will be extracted because suction is created in the sintering plant. Everybody knows it. And availability of water. As on today, we are sufficient or well versed with water, but days will come when you will not get water, particularly for industry purpose. That's all from my side. Thank you.
Good afternoon, Honorable Secretary. Good afternoon, dignitaries present in the dais and attending this conference as delegates. I'll be brief and I'll not be using any slides. Morning onwards, we are discussing a lot of points. So let me ponder upon these points and kind of reflect on that. Possibly that will help us to create the roadmap. The first thing what we have discussed is that, there's how the stories has to come up. Like, first thing is, what do we know so far? What are the hindrances ahead? The next thing is, how do you tell our story? How do you sell our story rather? And what kind of thing we do to manage this? The first thing which Professor Misra also said is, low grade by definition cannot be only the elemental content of the ore. It's also the mineralogical assemblage and their intricate associations. This is very important. I know for sure Australian universities are working on that very heavily. They are also generating costly data on that. So the next point is, when this data is being generated, how do we make good use of it so that the mine planning is well guided? Statistically, we do. There is a lot of scope in using AI/ML, though not yet well proven as yet. The next part is, when we go for beneficiation so long, when we are not worked with so much of low grade material, what have we done? Generally, we have a characterization report, which is not as detailed as I had just said in Australia they are doing. When you have this report, intuitively or through your wisdom, you think about certain equipments, and then you do certain testings at a bench scale, pilot scale, and then go forward for the setting up a plant. So by somehow we were a lot of equipment oriented or dependent flow sheets we make. When we go to the this kind of a low grade material, possibly we have to ponder upon the process in detail. For example, we all are talking about using magnetic separators, spirals for a fine grade material. Think about a situation where your material is so intricately associated, and then you grind it to so fine range that your magnetic force is not good enough to overcome the drag force that's being generated in the slurry. Or in certain cases separation, you need a segregation first through a gravity separation and then a drag force to separate it. But if they are not working good enough for this entire separation, so that's going to be more obvious. And also there will be another thing, as my previous speaker has said, that we will be slowly moving towards looking from body forces to surface active forces. Means we'll be looking at surface chemistry dependent separations, and such separations we need to be mindful that they are costly, they are selective, they are sensitive. So when you have such processes, you have to employ a good process knowledge and in data which comes out along the process knowledge, and the people who can handle such processes. So, people part is also very important. Do you have that kind of expertise present here who can handle such sensitive processes? So this is what is, days to come, this is what we need to develop ourselves. We also talked about that when you go for a, fine size beneficiation, you use lot of energy for grinding, lot of energy during processing. And this energy means to a great extent carbon footprint. We should not forget that. So one way we have a beneficiation things, but in the total value chain, we also need to see the sustainability aspect. When we go for, fine beneficiation and a low quality material, it's no magic that we will, at a most efficient process, maybe we will recover a good amount of valuable stuff, but we will generate more of waste now or reject. Now, what do we do with that? Yeah, we can make building materials, and certain studies had shown that some of these are good for even making agricultural use. But then, do you have that process in place to handle such a huge waste? And we should also be mindful that when we work in the process we are talking about, we'll be using a lot of water, which my previous speaker also said. Now, this water, a good chunk of it will go into the west side. So how do we manage, take that water out and be, going forward, be water neutrality aspect taken care of? So these are concerns which we need to address through better understanding of the process. Next point is that cost. All this process will come at a cost. Now, so this cost has to be seen that how it is, helping us in the downstream process. For example, we have spent a lot on the beneficiation, and we have got a huge enrichment ratio. Means you have upgraded a low quality stuff to a good quality stuff, but even then you are falling short in the quality of material you desire, people are looking for in the downstream operation. This falling short will have an effect in the metallurgical process downstream. Now, when you have that, then in a value in use, you have to see that what kind of impact it is making, and how do we, this community, can address that. Fine material, we all know, possibly we haven't discussed that well, that this kind of low grade material and fine material will also create a lot of issues in flowability. In our material handling process, particularly in the transfer points, fine material, which are little moist, having sometimes seasonal effect, will create problem in the flowability. Handling, as I said, that I'm repeating my other points, which is very important, is that how do we educate ourselves so as to handle this kind of plant. This kind of plants, for example, iron ore, one of the most efficient plant is in Cleveland-Cliffs at US. They have surface active reagents and all that. But do you have such kind of expertise here? Can we generate? Somebody talked about the reagent. Do you have a reagent which is tailor-made for us? See, US, they are a different kind of ore, they treat it. It's called taconite. So that's a kind of a different ore. Ours is a different ore. So whether that reagent is going to work very well for us, possibly not. So that also an area where we need to look at. A process-driven knowledge is a must for going forward. I think I'll not extend my talk further, and thank you for the patience hearing. Thank you so much.
And now we will request our chief guest for the day, Shri Vivek Bharadwaj ji, Honorable Secretary, Ministry of Mines, to kindly address the gathering.
I'm delighted to be here at the 12th India Minerals and Metal Forum. I remember our dynamic Secretary General, Mr. Rakesh Singh, coming over to me, because I've known him for many, many decades. And he was proposing that we hold a conference, and it was I who suggested that maybe we could have it on this particular topic. This is something which is very relevant, needs a lot of deliberations. I'm also happy to see that there are very eminent dignitaries on the dais. Mr. Jindal, the Vice President. Mr. Satija is an old friend. We have representatives from NMDC and GMDC. I have said this many times that metals, minerals are the foundation of civilization. Civilization as we know it in India, for example, started with the Indus Valley civilization. And those civilizations, those river valley civilizations, were called the Bronze Age civilizations, bronze, copper and tin. Then we graduated to the Iron Age civilizations. So metals and civilization have been linked forever and ever. India has been fortunate in being one of the largest producers of many of these minerals. We are the third largest producer of limestone. We're the fourth largest producer of iron ore, sixth largest producer of bauxite. So there are many of these minerals which we are abundantly endowed with. In fact, our rates of extraction are not very high, and therefore, at least for the next 50 years, we are comfortable with what we have. In fact, even today, our mining capacity is such that if demand were to increase by 20%, our mines will be able to produce that much. But what we don't produce is also very important. Just 2 days back, we released a list of critical minerals for India. In this country, while we may be the fourth largest producer of iron ore in the world, we produce no selenium, we produce no tellurium, which are byproducts of copper refining. That's always more important to be a processor than a primary producer. India has vast reserves of titanium. We export them, and we import titanium dioxide worth 1,000 crores. While I appreciate the discussion which has been happening till now, I think we need to refocus our attention on the minerals of the future. Gallium, which is a byproduct of refining bauxite. Indium, again for zinc, and tellurium and selenium when we produce copper. Many of these minerals we do not produce. Sometimes there are good reasons for it. One of the reasons is that they're economically unviable. There is this opportunity for the chamber to put up a policy paper on how we can make mining of these critical minerals or their extraction economically viable. Because today a time has come when price alone does not dictate the need for a metal. 20 years back, China abruptly switched off the supply of rare earths to Japan. The prices rose 4 times in 4 months. We've seen during the COVID epidemic where money could not buy you oxygen. Therefore, there's a need to rethink these critical minerals, that only economic viability is not a criteria. I presume that some fiscal measures would be needed, for which I'm sure the chamber would work upon. Apart from that, other policy measures would be needed. Today, when you extract an associate mineral, you pay the same amount of premium. That again might need a relook. The royalty rates of many of these minerals have not been specified. So they come in the residual category of 12%. That may also need a relook. These are initiatives which the Indian Chamber can take up, and I'm sure you will receive an adequate policy response from the government. Tailings is another area where we need to work upon. Mr. Bala has been very closely associated with the pilot project of tailings in the Kolar goldfields. We have 50 million tons of gold tailings there. Our understanding is that that is worth thousands and thousands of crores. We expect to extract not only gold, but also palladium from there. Unfortunately, in India, there are no miners who specify in processing tailings. This is again an area which is ripe not only for established industrialists, but also for startups, where they can focus on the technologies needed. We have a scheme for promoting R&D in mining. Unfortunately, the industry doesn't take adequate notice of it, does not utilize it fully. We have another research body called JNNRDC in Nagpur, which would also like to work very closely with industry. Unfortunately, the kind of research proposals that we get are not demand oriented, they are supply oriented. A researcher might like to work on some passionate project of his, and when we don't get adequate projects, that is what we fund. We are soon going to, we've in fact identified technologies that we are looking for, and we will fund research only in those technologies. You can understand that while critical minerals are found all over the world, 80% of processing takes place in one country. It is time that we looked at where we stand. The issue of low-grade iron ore deposits was raised, BHQ, BHJ. Unfortunately, we have a huge problem with this. The challenge is, how do we prevent misclassification? As soon as we notify a lower grade, somehow the deposit of the mine changes from X grade to Y grade. And this is not something unusual. It's happening all the time. This misclassification of grades is what is preventing us, because unfortunately many of us are into gaming the system, not working the system. And until and unless we become more conscious of what we are doing, it will be the same response of the government. The government wants to trust, but then trust begets trust. So I would ask you to devise a framework where this misclassification does not happen. It is only then that we will look at this BHQ, BHJ grades. I believe this is truly Amrit Kal for all of us. I believe this is the time for us to get together, look at what we've been doing with different eyes, recheck, recalibrate our responses, look at new processes, how we can value add. I think this is a time for change. This is Amrit Kal. Thank you.
Thank you. Thank you very much. If we will take a couple of questions from the audience. Yes, sir.
Hello.
Yeah.
Hello, I'm P.K. Chatterjee from Indian Institute of Metals. Sir, we understand that India has been allotted about 150,000 square kilometer of mine site in Indian Ocean for survey and exploration. But nothing much has been done. There is nothing much progress in that area. You will agree, sir, that ocean bed is a rich source of minerals. So there may be some more coordination is needed between Department of Mine and Earth Science. So what is your viewpoint, sir, on this issue?
I'm presuming that the question is addressed to me.
Yes, sir. The question is addressed to Mr. Vivek Bharadwaj, Secretary.
Let me make a small clarification. The jurisdiction of the Ministry of Mines extends to the continental shelf and to 200 miles, nautical miles, okay, which is our exclusive economic zone. Beyond that, the deep sea, which is the jurisdiction of the Ministry of Earth Sciences, right? That is the first thing. Two, we have an act which was enacted in 2002, Offshore Areas Mineral Development and Regulation Act. Unfortunately, the act refers to the old licensing regime of first come, first serve. We have put out in public consultation the need and a draft for a new act, or rather amendments to the act, which will incorporate the new auction regime. The proposal, the amendments are awaiting cabinet approval. If all goes well, we might introduce it in the monsoon session. And thereafter, we are ready to auction blocks in the offshore areas. Thank you.
Thank you, sir.
Hello. Sir, there is one critical issue, sir. This is starting with the decarbonization. Now government is coming up with a policy framework. Around 14 task force are working on this, sir. Beneficiation is crucial, for which the materials efficiencies have to be improved. I mean to say that, for example, in the case of steel making, so the norm may come that the Fe has to be less 65% because of the new technologies which are coming for decarbonization route. However, unfortunately, sir, you might be aware of it, sir. After the auction, the beneficiation has become absolutely impossible for producing concentrates because of the royalty on the premiums. So I was part of that one company, sir. We were not operating, we had a 5 million ton beneficiation plant, iron ore, in Barbil area, Odisha. We had a slurry pipelines and all the things we had. However, we were never able to run the beneficiation plant because the cost of concentrate of beneficiation is higher than the high grade ore itself only. Many of the iron ore beneficiation plants, they were idle. When they buy the iron ore, converting to concentrate is very high, sir. And now it is further changes happen. If I buy iron ore, because the low grade iron ore cost itself is high because of the royalties and premiums, and converting that into high grade concentrates, it's very difficult, sir. This is because of the tax structure, it has become an impediment, sir.
I've understood it, I'll tell you. So nobody thought of royalty on royalty till the Ministry of Coal actually amended their rules. Please sit. And then everybody started talking about royalty on royalty. Now when you bid for a mine, royalty is one part, right? The other is the premium, right? At times the premium is 400%. Usually it is say 50% to 100%. How much is your royalty? Maximum 12%. What would be the amount of royalty on royalty? Have you made that calculation?
Done, sir. We did it.
So it is not a very large proportion. We have made these calculations. It is very easy to flag an issue, difficult to support it with data or even with common sense. If you have 400% premium being paid, why will the gentleman not pay another maybe a few more percentage? And nobody ever, let me tell you, I don't know if you bid for mines, no, an owner never bids for a mine thinking this much I will pay for DMF, this much I will pay for royalty, and this much I will pay for NMET. He calculates a lump sum. पोसाएगा कि नहीं पोसाएगा? ठीक है, ये होता है इस तरह. That is how the market works. But if you want me to give you a formal answer, the formal answer is we've set up a committee. The committee's report has been received. We are examining it and we'll get back to you.
Thank you, sir.
Yeah. Hello, I'm Rajiv Agrawal.
Sir, we are talking of iron ore beneficiation, a lot. But when we see the actual, the iron ore, the capacity of the iron ore plants at the site, I mean, all these plants which are installed, they are not fully utilized. If I am correct. The mines operators are not utilizing those iron plants. I don't know for what reason, maybe some deficiency in regulations. Say, suppose the iron beneficiation is 4 million tons, they are hardly using it for 2 million tons or 3 million tons. The present capacity of the beneficiation plant, particular iron beneficiation plant I am talking,
क्या होता है
they are not being fully utilized.
जीवन में क्या होता है ना कि हर आदमी को मुश्किलें आती हैं, उतराव चढ़ाव देखता है आदमी, ठीक है? तो हर चीज पे तो बीवी पे थोप नहीं सकता है, कभी कभी सरकार को भी कहना पड़ता है ना? तो हर चीज सरकार की वजह से नहीं होती, कभी कभी किसी और से भी हो सकती है.
Hello, I'm Rajiv Agrawal. I'm Secretary General for Indian Captive Power Producers Association. Sir, you have rightly raised the points related to cost for beneficiation. Then there are costs which are related to environment, which every industry wants to do. But then one thing is cost of energy is almost 30% to 70% for metal manufacturing processing taken together. Now, there is a big anomaly which has historically come up, and I need your attention since you have already worked in coal
so you know it maybe, that for a private sector, pithead coal cost is around 350 to 500 rupees. Whereas Coal India, for whatever historical inefficiencies, is around 1150 rupees. That coal is sold for around 1500 rupees to government power plants and for almost 2500 rupees to private sector. Now, over and above, you get 400 rupees green cess and royalties we have already discussed. Now, this has created an skewed situation wherein everything, be it minerals, metals, cement, everything is becoming so costly that on parity, India is not able to create any demand. And since demand are not being consistently created, there is a long-term effect on the whole economy that we are witnessing. But still what we are trying to do is go for subsidies to some sector, some people, and spend much more in terms of inefficiencies. Sir, I need your attention that this is a time that we do this correction in a very serious manner. Thank you, sir.
देखिए, ऐसा है कि मैं किसी भी सभा में जाता हूं ना, मैं सबसे कम जानकारी मुझे होती है। आप सब हैं एक्सपर्ट्स, ठीक है, मुझे सबसे कम जानकारी है और आशा प्रत्याशा मुझसे सबसे ज्यादा है। तो ज्यादती है ना? So I'll now give you a formal answer which you want to hear. You see, the very fact that the government has opened up the sector means that there is competition. You already have commercial mining. You will have more and more commercial miners coming in, and there will be competition. You do not certainly need to take coal from Coal India, maybe in a couple of years. And this is the best way to bring in efficiencies.
But sir, there also, unfortunately, since everything is on the forward auction basis, linked to index, which is nowhere near to reality.
My dear friend, for the last 8 years, Coal India has not raised prices. I was abroad for a year. I came back and I asked for a cup of coffee in this country, and I was told it's now so much. I said, क्या हुआ? तेल के दाम बढ़ गए क्या? For no reason at all, we raise prices, sir, in the industry.
Sir,
I have no idea why. So let us not get into prices. The best thing to do is to increase competition. There is no other way but to increase competition, which the government has done. Okay.
Thank you, everyone. And now I would request Mr. Pankaj Satija, co-chairperson of the ICC National Expert Committee on Minerals and Metals, for summing up and the vote of thanks.
Thank you, Nilanjan. Shraddheya Sri Vivek Bhardwaj, Cyanosphere of all the eyes, Mr. Abhyuday Jindal, Mr. Dr. Mohan Yelisetti, who has joined online, Mr. S.K. Chaurasia, Mr. A.K. Mukherjee, and Professor B.K. Mishra was moderating the session, and all the dignitaries of the days. There is a very beautiful word in national mineral policy. It's known as mineral conservation, and very aptly defined that mineral conservation should not be seen as a preservation or its abstinence. Rather, it should be seen in a very positive manner, either augmenting the resources through discovery, through beneficiation, or through mining methods. And many of the people in the industry are working towards it. It reminds me one of the story of a person who was from the indigenous tribe, resides in Jajpur district. Once upon a time, he came to his native place on a holiday, and while he was traveling or passing his time in the holiday period, he came upon a very shiny piece of stone. He took that stone to an R&D lab in Jamshedpur, And those researchers, they did work on that stone and came out that this is chromite. In 1950s, the process started, and 1960, chromite mining started. In 1989, the miners realized that there are a lot of low-grade ore which is not being realized. So 1989, they collaborated with MDL, Mineral Deposits Limited of Australia, and beneficiation started. Why I brought the chromite story here? Because if you see the coal mining, it started somewhere in 1774 by Hunman and Hitley of East India Company. And chromite mine started in 1960s and beneficiation started in 89. The journey from discovery to beneficiation and further upgradation was very fast compared to other minerals in India. I'm not casting aspersion on coal mining people, but then the point what I'm making, there are many factors which made the chromite mining to faster moving towards the beneficiation. And it also reminds me one of the shlok that amantram aksharam nasti, nasti mulam ausadam, ayogya purusha nasti, yojaka tatra durlabha. There is no letter from where a mantra or shlok cannot start. There is no plant which doesn't have a medicinal value. And there is no person who is useless. What we lack is the enabler. So in that time, the person from the indigenous community, Katepurti, he was the enabler. The person with the R&D lab, they were the enabler. And we have Mr. N.D. Rao, who was the one behind the beneficiation of chromite mine. He was also one of the enablers. And that's the success story of beneficiation in India. The story also moves towards the other part of the world also. So 1996, Western Australia came out with two different acts. One was Iron Ore Beneficiation Agreement Act and Iron Ore Direct Reduced Iron Agreement Act, 1996. And BHP came with a project in Budari, and Rio Tinto came with a project in Kwinana. Many factors associated with that, the project could not come up. But then there are success stories also with Alcoa on aluminum and Tronox on sand minerals. And as previous speakers were mentioning about Goa versus eastern part of India. So Goan minings were a bit ahead in processing. They have magnetic separator much before, or hydrocyclone much before the eastern part of the India. And in Goa also we have seen the two deposits which are very close. One case magnetic separator worked out, in other it doesn't. And Dr. Mukherjee was asking on a very particular point of mineral characterization study. So what we should try to do from learning from the different success stories and failures, that each deposit is different and we need to have a customized approach depending upon the different beneficiation techniques what we have to make better use of it. In words of Wasim Barelvi, हर शख्स दौड़ता है भीड़ की तरफ, फिर चाहता है कि रास्ता भी अलग मिले. So if you want to have your own path, don't just follow the crowd. Try to know the deposit, what you have, and then customize a mineral beneficiation technology depending upon the minerals. So in recent times, what other speakers have also mentioned, that a lot of AI and machine learning also has come, apart from the technology of spirals or magnetic separator. So long short-term memory, convolutional neural networks, support vector machine, deep learning algorithm. These are some of the algorithms which are being used by the different beneficiation companies. And Rio Tinto has also worked on copper new wave in a copper project in USA. Of late, what we have seen that many mining institutes, they have started producing, or people are graduating from mineral processing. But if you see in the industry, they either switch to maintenance engineer or the operation engineers. Probably we do not have a cadre or career progression plan of mineral processing engineers, and that was also being talked about by the speakers, that we need to have expertise of people, those who understand, or those who know the enablers. And industry must make a career progression plan or a different career path for mineral processing engineers so they can continue in this field and come out with better and better expertise. Bhagavad Gita also says that Shreyam Sarvadharma Viguna. Paradharmat Swarnishchitat. It's better to do your own job with little imperfection rather than doing other person's job with perfection. So mineral processing engineer, what has they, because of the regions, they moved towards maintenance or operations and left their own core job. And that's why when we say that we need expertise or we need people who are good in mineral processing, probably industry has to introspect and reflect. With this background, I would like to thank first of all Bhardwaj Saab. He brought out many points for the industry. He emphasized on critical minerals, and we should refocus our work, how we can make mining of these critical minerals viable. He also emphasized on the geopolitical scenario which emerges out of the critical minerals. Relook at the policy response. This is the job he has assigned to ICC. He also emphasized on how we can unlock the value from the tailings. He gave example of Kolar Goldfield. A startup, R&D, and how the industry should come out with the research proposal, not on the passion, but on the demand-supply dynamics. He mentioned the Amrit Kal period and urged everyone who are here to utilize or take use of this Amrit Kal period, come out with the new process, new thinking, new ways, and new thoughts. He mentioned a very particular point: trust begets trust, and we need to be transparent of what we report and transparent in the discussions what we do with the policymakers. Thank you very much, sir, for your thoughts and your vision. Mr. Jindal, while in welcome address, he emphasized on incentivizing the beneficiation, promoting beneficiation of BHG and BHQ, alumina content in iron ore, and how we can have improved technology. Thank you, Mr. Jindal, for highlighting those points. Dr. Mohan, while he was online, but then he also gave example of 30 gold tailings, deeper property and leaner grade. This was the mantra he gave, that as we are progressing towards in the mining from the last history, we are going to have a deeper deposits as well as leaner grade. He also brought iron ore story of Goa and trends in the mineral beneficiation and new ways to produce critical minerals. So thanks to Dr. Mohan also. Mr. Chaurasia, he emphasized on slurry pipeline, trade-off between blending and beneficiation, and the different projects he is taking of different corporates and companies. Thank you, Mr. Chaurasia. Dr. Mukherjee, he emphasized on characterization report, bench scale, pilot scale plant, expertise in mineral beneficiation, and also to look forward on the sustainability aspects of the mineral beneficiation. With this, I thank all the dignitaries on the days. But when there are speakers, there should be some listeners also. Otherwise, who will speak? So I thank all the audience, those who are here, and for your patient hearing. Thank you very much.
And now, may I request Mr. Abudhay Jindal, Vice President ICC, to kindly hand over a token of appreciation to our chief guest, Shri Vivek Bharadwaj ji, Secretary, Ministry of Mines, Government of India. I would also request Mr. Abudhay Jindal to kindly hand over a token of appreciation to all our speakers. To Mr. A.K. Mukherjee, to Mr. B.K. Mishra, to Mr. Pankaj Satija, and to Mr. S.K. Chaurasia. Once again, I would like to thank everyone for being with us. We'll break here for lunch. And I will request everyone to kindly join us back because we have a post-lunch session as well.
Hello, all of you are requested to join for lunch, please.
ओके सर को मैं बोल देता हूँ हाँ ओके मैम ओके मैम चश्मा है क्या कोई चश्मा कोई किताब दो ये दो
Yeah, hello. अनन्या, अनन्या का नंबर है क्या तुम्हारा?
Sir, join. Hello. Yes, ma'am. Okay, ma'am. Okay. Okay. Secretary, ma'am. Coming.
फोन ये है क्या? क्या नंबर?
नहीं, ये तो सर इंटरकॉम।
फोन है नहीं क्या इसमें? यहाँ पे फोन ही नहीं है क्या?
नहीं,
डायरेक्ट लगाने के लिए कोई जीरो वीरो ऐसा नहीं है?
नहीं सर, लैंग्वेज नहीं ले रखा सर। सर रिसेप्शन।
Yeah, good afternoon and welcome back. May I request all the delegates to kindly take your respective seats. Secretary Steele is already here and will start in 2 minutes. I would request everyone to kindly come to the and join us back.
Hello. 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 Given. Hello. Yes, ma'am. Yes, ma'am. Yes, ma'am. Okay.
What did you
2
say?
minutes.
मिलोगे तुम इससे?
या सर ये अपना एक शेड इधर का अपने यूनिट 1 के सामने का एक शेड यही बना रहा है सर.
अब यही बना रहे हो जो उसका लोग ही नहीं आए हैं. इसका प्रेजेंटेशन है क्या तुम्हारे पास? क्या आज क्या पूरा राइट अप आया हुआ है क्या आज का? नहीं, इसका ये प्लेम्बर का
Yeah, good afternoon, ladies and gentlemen. Once again, I would like to welcome you all to this post-lunch session. We are really honored to have Sri Nagendranath Sinha, Honorable Secretary, Ministry, with us as the chief guest of this session. This session would focus on Make in India and Steel Outlook. And now may I request our chief guest, Sri Nagendranath Sinha, Honorable Secretary, Ministry of Steel, to kindly join the dais. I would also request ICC Vice President Mr. Abhyuday Jindal to kindly join us. Mr. N.D. Rao, President Projects from Avalgam Steel, to join us in the dais. Mr. Shantanu Roy, Director BEML, to kindly join us. And Mr. P.K. Satija, Co-Chairperson of the ICC National Expert Committee on Minerals and Metals. Mr. Brij Bhushan Agarwal, who is VC and MD of Sham Metallics, will join us online. Unfortunately, Mr. Manish Kharbanda couldn't make it due to some health issues at the last moment. I would also request Mr. Himanshu Singh, Director Strategy, Aluminium Business from Vedanta Limited to join us. The session would be moderated by Mr. P.K. Satija, and now I would request Mr. Abhuddha Jindal, Vice President ICC, for the welcome remarks.
A very good afternoon and a warm welcome to everyone. I'd also like to welcome our chief guest, Honorable Secretary, Ministry of Steel, Shri Nagendra Nath Sinha Ji, Director, Mining and Construction Business, BEML, Mr. Shantanu Roy, President, Projects, Amalgam Steel, Mr. N.D. Rao, VC and MD, Sham Metallics, Mr. Brij Bhushan Agarwal, and Mr. Himanshu Singh, Vedanta. And our co-chairperson, ICC National Expert Committee on Minerals and Metals, Mr. Pankaj Satija. It is my honor to welcome all the speakers on the occasion of 12th India Minerals and Metals Forum, organized by Indian Chamber of Commerce. We are happy to organize this forum in association with Ministry of Steel, Government of India. On behalf of ICC, I thank our chief guest, Shri Nagendra Nath Sinha, Secretary, Ministry of Steel, to make time for this event. Your participation gives industry the confidence that our government is fully invested in creating an Atmanirbhar Bharat, and the local for global is the way to go. Metals have been one of the core drivers of industrialization, and among others, steel has always held a dominant position. As a raw material and an intermediary product, production and consumption of steel are widely regarded as indicators of economic progress. Steel industry has been at the forefront of industrial development and forms the backbone of any economy. India is the new powerhouse in global steel production. As per the World Steel Association, India was the only large producer to increase output amidst a global decline, up from 118 million tons in 2021 to 125 million tons in 2022. China's production fell for the second consecutive year. Even in stainless steel, India consumed over 3.9 million tons in FY23 as against 3.6 million tons in FY22. This growth of 6 to 8% witnessed in the steel and stainless steel sector can be ascribed to the government's vision of increasing the share of manufacturing sector to 25% of the GDP by 2025. As India aspires to become a 40 trillion economy by 2047, sectors such as construction, infrastructure, and manufacturing will propel the growth of steel and stainless steel. By these estimates, the annual steel and stainless steel production will reach 500 million tons and 200 million tons and 20 million tons by 2047 respectively. While this presents a great opportunity for major and ancillary players in the Indian steel industry, it also exposes us to unfair dumping practices by countries having excess steel and engineering good capacity. India's domestic steel industry is therefore facing dumping of subsidized imports, demand fluctuation arising from a global wave of protectionism, and trade wars between countries affecting the overall growth and profitability of Indian steel industry. However, looking at the past growth pattern of the industry, we believe that this is a temporary phase and will definitely be mitigated by proper policy support from the government. I would also like to truly appreciate the production-linked incentive scheme introduced by the government in the area of steel. The PLI for specialty steel, with an outlay of 6,322 crores, is expected to attract additional investment of rupees 10 lakh crores in the industry by 2030-31. The industry is also looking forward to PLI 2.0 for stainless steel and special steel alloys to further enhance our technological prowess and export potential. Other initiatives such as establishment of project development cell in the ministry to attract and facilitate investment in the steel sector, the new steel policy 2017 under Make in India initiative to achieve 300 million tons of steel making capacity by 2030, the domestically manufactured iron and steel product policy for promoting procurement of made in India steel, steel scrap recycling policy to enhance the availability of domestically generated scrap, issuance of steel quality control orders to stop manufacturing and import of non-standardized steel, Steel Import Monitoring System, also known as SIMS, for advanced registration of steel imports, and ongoing efforts to bring in more and more steel products under Bureau of Indian Standards are commendable steps taken by the Ministry of Steel for promoting and protecting domestic steel industry. Apart from the above policy measures, steel sector is also home to digital transformation and emerging technologies. Larger steel players have made good progress on this front with technologies such as digital twin of blast furnace for optimizing operations in real time, artificial intelligence, and advanced analytics-based digital tools, robots, drones, 3D printing for core operation areas like procurement and supply chain to improve the working capital, enhance service levels, and also save costs. Even in the area of sustainability, our sector is leading the way for carbon reduction goals. At Jindal Stainless itself, we have already switched to renewable energy alternatives to power our new capacity expansion. We are also the first stainless steel company in India to set up a green hydrogen plant. I also speak for the smaller and mid-sized steel and stainless steel manufacturers who contribute about 40% of our industry output. This part of our industry needs government support to help them adopt modern technologies and ensure higher productivity and a circular economy. On the country front, high cost of logistics, lack of skilled manpower, underdeveloped infrastructural framework, lack of green grids can prove to derail the growth potential of the sector. The government has already introduced a slew of measures to address these issues, and we are fully committed to support the government in all such initiatives. The Ministry of Steel, led by a dynamic and decisive minister, is already in the know of challenges that threaten the prospects of domestic producers, and also the opportunities that can push India steel to world markets. For industry to truly realize the Make in India dream, the sector counts on a three-pronged approach with proactive government support. One, a consultative decision-making process to capitalize on competitive advantage of Indian steel players. Two, quick and responsive trade and non-trade remedial measures to counter global trade wars and effects of damaging imports. Three, a cohesive growth plan to capitalize the fortune at the bottom of the pyramid, while also aiming for the niche value-added segments. I look forward to listening to the views of my experienced and knowledgeable fellow speakers, and thank you all for being here. Jai Hind.
Thank you, Mr. Jindal. He highlighted many points. Importance of steel industry as a backbone, the GDP contribution, PLI, SIMS, and decarbonization strategy. With this context setting and welcome note, I would request Sri Brij Bhushan Agrawal, VC NMD Shyam Metallics, to share his thoughts.
Hi, good afternoon, everybody. And it was very well taken from Abhyuday. Like most of the point he has already covered on the steel front. And I must congratulate and appreciate the change in the policy, in the new governance in the steel industry, what we had been abiding in time to time, you know, the PLI scheme, the decarbonization policy, and a lot of new innovations are happening in the steel industry. As we all know, the vision of 300 million ton is, with the seeing the present GDP, doesn't look very difficult. And we are seeing how in the toughest time, all the steel industry in our country, they have done pretty well in last 3 years, in spite of such a tough geopolitical situation where worldwide we are seeing that the major industry has suffered, you know, on the ground of demand or energy, but India has come front and has taken the good lead and has shown an excellent performance. I would say about Shyam Metallic, like it has in this company, like we are in the different products, starting from, you know, the pallets, the DRI, the long product, the wire rod, the wires, aluminum, specialty alloy and stainless steel. We are doing a massive expansion in all the product where we are right now. We have a presence with our new initiative of the government in the demand of the stainless steel and aluminum. We have just now acquired the plant Mittal Corp, and we are planning to expand in the stainless steel business in next 3 to 5 years with targeting a revenue of around $1 billion in this. And apart from that, we are also putting up a flat product plant in the color coated space in the carbon steel. And today, we are also making a specialty alloy. We are country largest, and we are developing a lot of new innovative alloys where we are seeing a lot of replacement of the imports and the specialty alloy business in specialty steel. What is developing in the country, we see there's a lot of need, and we are developing a lot of new product as well. So nevertheless, I would like to make it very stream. Like today, the aluminum business, what we commissioned last year, is a world-class facilities. And today we are country number 1 in the aluminum foil business. 70 to 80% of the product what we are making, we are exporting to the best of the world market. And we have developed a lot of product in the defense as well in this space. And we tend to grow in all these spaces of aluminum, stainless steel, and other special steel of our present product mix. And thank you. I would like to make it very short and brief. Thank you all.
Thank you, Mr. Brijbhushan. You highlighted your company prospects and the way you are going to move forward. Now I'm going to invite Mr. Sandy Rao. He himself is an institution as a Dell, Tata, and the mineral wise also, zinc, chrome, iron ore. I have learned from him whatever I am learning today also. I can proudly say that I am a student. Sir.
Good afternoon, everybody. Respected Secretary Steel, Nagendra sir, and Abhyuday ji, and other dignitaries on the dais and off the dais. Thank you, ICC, for inviting me to be present here. Sir, I would like to first, before going to the challenges, I am from Amalgam Steel and Atha Steel. We are into the mining. We do mining, we do beneficiation. Morning we have discussed it. We do BMQ beneficiation from 25, 30 grade. We enrich it up to 63, 64, 65 grade. We are operating very low grade iron ore beneficiation plants. And also we are into pelletization. We are into DRI. We have three units. We are into billet steel making and power generation. Currently, I am working on integrated steel plant project, slurry pipeline project, and pelletization plants, and iron ore beneficiation projects I am leading for both the groups, Atha Group and Amalgam Steel. The biggest challenge for the steel sector right now, sir, your Ministry of Steel is working very actively on decarbonization. That is the biggest challenge each one of us, whether we are in the beneficiation, mining, steel, any other sector, particularly for aluminum sector. And each one of us, the biggest target and challenge for all of the industry colleagues is decarbonization. Sir, particularly for the steel, the biggest challenge of decarbonization in steel is, even though our country blessed with good iron ore deposits of good grades also, unfortunately, most of our deposits have high alumina. And that is what is adding more and more carbon emissions in our steel plants. Basically, we are blessed with rich iron ore, but iron ore mostly it is fines in nature. And that needs to be agglomerated to use it in the steel making, either in the primary metallurgy, that blast furnace route or DRI route. Agglomeration is required. When iron ore with high alumina sintering agglomeration predominantly starting for the last several decades. So the moment we convert high grade through sinter process, because of alumina, lot of MgO, CaO has to be added to get the strength to withstand in the blast furnaces. That results in many of the PSU steel plants even till today, the slag rate in the blast furnace. For 1 ton of hot metal, it goes 400 kgs, 500 kgs. I was doing assessment for Vizag Steel Plant on behalf of CII for Rajiv Gandhi National Quality Award. That time their slag rate used to be 500 kgs per ton of hot metal. That was, sir, in the year 2006. So the world lowest slag rate per ton of hot metal is 165 to 180 kgs. That is LCAP, Sweden. 2 reasons. Alumina is less than 0.5%, sir, and they charge 100% pellets. So the lowest slag rate means lowest carbon emissions. We need not spend more on coke addition, and the blast furnaces productivity also goes much higher. Even today we are talking on PCI, pulverized coal injection. The more you charge pellets, the higher the PCI, higher the productivity. That is there in the DRI also. So sintering per se is not a bad process. It is also a good agglomeration process, but unfortunately alumina makes it difficult, for which the only solution is beneficiation, sir. Through beneficiation, the alumina can be brought down, like Tata Steel has set up beneficiation plant long time ago. They brought down the alumina level to below 2% from 3.5 and all the things. But ideally it should be below 1%, sir, it is required. Otherwise our emissions will go on increasing during the agglomeration process. Therefore, the challenge for beneficiation today is the new technologies, particularly to take from the cutoff grade of 45% cutoff grade of low grade ores to take it to 63, 64. So for the decarbonization today, the materials efficiencies have to go up to, particularly with respect to steel, it has to be plus 65%, up to 67% is required when we go into the future technologies of DRI and arc furnaces. That is, I think 90% reduction in the emissions is going to happen through that steel making process. In order to improve the materials efficiency, today, unfortunately, because of the complexity of most of the Indian deposits, we don't have technologies to do that. That is one thing, sir. Another thing, the reduction roasting process is there. At pilot scale, it is successful. But again, there we have to go up to a temperatures, carbon addition to around 1000 degrees is required in the kiln to do it. So that itself, again, carbon emissions are there. The biggest challenge for this is the economic viability is a questionable, sir, as of now. Commercial plants have not yet come for the reduction roasting process. It is not a new process. This technology was in use Kazakhstan several decades ago. They were doing it, which I myself have seen it. But there it is natural gas. So that's why economically viable for them to do it at 800 degrees centigrade. They were converting it, sir. Sir, added fuel to the fire is, sir, post-auction. The low-grade ores convert into high-grade ores. It is disincentivization for that, sir. Because of the taxation policy, again, I'm coming back to that. The royalties structures are different. There is no incentivization for beneficiation of iron ore. It is economically not viable, sir. Several beneficiation plants in the past, they have invested, but they were not operating it, just they were grinding and converting into pellets, and they're doing, sir. So that is a policy initiative, sir, which is required to be taken care, sir. Sir, another important thing is the logistics challenge biggest in India, sir. The cost of logistics in India is one of the highest in the world, sir. Sir, the national steel policy says by 2047 we have to be a 500 million ton steel producer, for which 800 million tons of iron ore is required. And the total cargo to be handled for a 500 million ton steel production means 2 billion tons of total cargo to be handled, 1:4 times. Sir, Indian Railways capacity today is, I think, some 1.4 billion tons, I think so. So to handle only for the steel industry 2 billion tons, then what about the other cargo and how this is likely to happen, sir? There is a solution available, sir. Technically, solution is available to handle it. Provided governments with a policy that incentivization of minerals transportation through below ground slurry transportation, sir. It is technically feasible and different capacities can be done, sir. Sir, in 2016, the then Secretary Madam Aruna Sharma ji, we had several meetings. I was heading the Pellet Manufacturers Association of India. She asked us to submit one national level grid, like oil and gas grid pipelines, slurry pipelines, connecting all the mines in India, iron ore, and all the plants and upcoming plants, sir. We have given, me and the engineering company, sir, Mecon, we have submitted, sir, one national grid of slurry pipelines. We have given, sir. Then the policy framework has changed and they have giving National Highways also started giving the ROWs for laying the slurry pipelines, sir. But, sir, at that point of time, there was one meeting, Railway Ministry also accepted. They said that we will give you ROW for slurry pipelines, sir. But unfortunately, sir, till now it didn't happen. I'm just saying it is 2016-17. The Secretary Madam told, yes, they have agreed it, but sir, till now it didn't happen, sir. Sir, why slurry pipelines is not only taking care of the logistics cost, sir, it is the carbon emission reduction will be 90% comparing to the surface transport either by road or by rail, sir. 90% reduction in carbon emissions. Energy conservation comparing to surface transportation as per the US EPA calculations, 98% energy conservation. To transport 1 ton of iron ore through this route for 300 kilometers, sir, it just takes 3 units of power, 3 to 3.5 units of power. Such a low cost and high energy efficient system, sir. Another problem, sir, interstate transfer of slurry transport, one state to another state. Suppose their plant is in another state, their mine is in one state, and the lessee wants to take it, the plant wants to take it, but unfortunately, the interstate slurry transportation, the permissions are not given by the state government, sir. There are some issues. Within the state, it is available, but state to state, sir, it is not available. That is required, sir. Sir, the slurry transports, it has proven that it goes below the ground. It uses the latest technology that is called, you can say, Industry 4.0. It is, the slurry pipelines are operated autopilot mode, and it can be operated from the receiving side, terminal side, or the pumping side also. And the transportation of the mineral goes, any mineral can be transported. So the first transportation of the minerals have come for coal transportation in USA in 1960s because the logistics, the freight has gone very high. Then this innovation has come, the transportation through that, sir. No Bharat Bandhs, even Bharat Bandhs are also there, the transportation will go. No COVID, even during COVID time also, those companies were operating which were having slurry pipelines, those steel making plants were in operation. And anywhere leakage happens anywhere, it is so high tech that you will come to know immediately the alarm, it stops, sir. Even if somebody tries to sabotage it also, it uses very high technology. Immediately the alarm comes and it stops, sir. And as far as cost is there, logistics cost, the rupees per ton per kilometer, suppose somebody wants to take the iron ore from mining area to port, like Barbil, Kevingir district to Paradip port, by road, it takes around 5 rupees to 8 rupees per ton per kilometer. If it is by rail, it takes somewhere 2.5 rupees to 4 rupees, different routes they divert. If it is slurry pipeline, I am just giving one case study. If you transport 30 million tons for around over 300 kilometers, it comes around 1.8 rupees. That is in the first 1 or 2 years. Afterwards, it comes below 1 rupee. So the costs are, the capex is there, but the payback period is faster, 3 years or 2 years, sometimes even it's 1 year also. Those things are possible, sir. Sir, but the national policy is required on this, particularly for the purpose of decarbonization and also achieving the target of 500 million tons of steel production by that period of 2047. And commercial, sir, one commercial slurry pipeline can be kept because everybody cannot set up a slurry pipeline, which is a very high cost, capital incentive. Like Amazon model, door delivery can also be there. Like NMDC can put up a slurry pipeline, deliver to all his customers at different destinations. Technologically, it is possible. It can distribute at the door delivery. Even companies like in Orissa Mining Corporation and NMDC, they can do this. They can deliver at the door to the user agencies, the customers. So low carbonization technologies we have discussed. The biggest challenge is that the handling renewable energies one there. In the mines, sir, there are a lot of areas which are not in use like dumps and whichever areas are there, I think we suggest to the government to come up with a policy that Indian Bureau of Mines that the dumps, old dumps, they can be used to set up like solar power systems and some other places wherever the mining doesn't take place. Policy framework can help to put up that so that that power can be utilized in the mining operations purpose also, crushing and screening purposes also it can be done. IMMT was talking about it like this plasma technology, hydrogen plasma. IMMT Bhubaneswar has done it. I think the director is here. They can further take it to that, how that technology will help us for the decarbonization purpose. So regarding the digital technologies, first the industry, particularly steel also have started with PLCs, then started with SCADA, now Internet of Things and Industry 4.0 and AI and ML, artificial intelligence and machine learning. Technological changes are happening, sir, that will improve the overall performance of that. Here I would like to give one case study where the technology is not used and how they have suffered. One case study, one pellet plant in India which produces 3 million tons of pellets. since they did not go for a most appropriate technology, their fuel consumption used to be around 70 liters per ton against a standard of around 15 liters. So they have compromised on, say, around 20 crores, but they used to lose 90 crores per year. And like that, in 3 years, ultimately they have to shut down. And another plant also, which I know, their fuel consumption also used because they did not go for the burners automation. They did not go for digital technology, and therefore they used to lose around 97 crores per annum, and they have lost. Another plant also, they didn't go for technology upgradation in that, but they used to lose a lot. So average lifespan of a company or corporate today is around 18 years. It is projected to be around 15 years by 2030, and by 2035 it is going to be 12 years, average lifespan of a corporate.
Sir, if you can
These
conclude.
changes are happening
If you can
So-
conclude, sir.
because of digital technologies changing it very fast. Those who embrace the digital technologies, automation, they could able to average lifespan will be much higher. Thank you very much, everybody. I think I have taken more time.
Thank you. Thank you, sir. You spoke on decarbonization, high alumina, lowest slag rate, pellets, new technology in beneficiation, cost part. You touch on royalty, logistics challenge, slurry pipeline grade, energy conservation in transportation, industry 4.0, cost of slurry transportation, national policy towards it, commercial slurry pipeline, door delivery like Amazon, handling renewable energy, dumps and solar power plant, and then IMT, plasma technology, and the case studies on pellets. So it's a list of topics you covered, your wish list, our wish list. And I was thinking of couplet of Mirza Ghalib, Hajaron ख्वाहिशें ऐसी कि हर ख्वाहिश पे दम निकले. With that, I would request Mr. Himanshu Singh to share his thoughts.
Respected Secretary Steel, dignitaries on the desk, I'm Himanshu Singh, I'm presenting Vedanta. Just a brief about Vedanta. It's a household name in natural resource sector, but still as a customary introduction. So, we are the largest zinc manufacturer in the world, largest aluminum manufacturer in the country, one of the largest oil producer. We are into iron ore, we are into steel, we are also venturing into new sectors such as semiconductors, LED panels. Yeah. So starting with aluminum, though it's a steel session, but I'll first take about aluminum because it's one of the sectors we are present into, and we are the largest aluminum producer in the country and third largest in the world. We currently, India has 4 million ton of capacity in terms of aluminum. In terms of just million ton, it may look small compared to steel, but in terms of value, it's huge. For every ton of aluminum, we require 22 tons of movement of other materials. So it's around more than 80-90 million tons of bauxite plus alumina plus coal plus everything. So, and given the projections of Ministry of Mines, we should be reaching around 10 million tons of capacity or the demand by FY30. For that use, around 6 lakh crore of investment is required, because 1 million ton of aluminum manufacturing capacity requires 50,000 crores of investment. It's a heavy capital intensive business. And by the way new sectors such as RE and EV are coming, the lightweighting is happening in most of the sectors. Aluminum is going to replace steel in a much faster way. Now you see larger applications of aluminum in cars, in other utilities. Just this is an interesting chart. If you see a country to be sufficient or powerful in aluminum, they need four attributes: bauxite, source of power, labor, and the right market. And among top 10 countries in the world who are producing or consuming aluminum, only India and Brazil have all four ticks. Interestingly, China, which is not having any bauxite, is holding more than 50% of aluminum capacity. They are importing bauxite from Australia, they're importing alumina from Australia, and they are building aluminum and selling across the globe. Just a comparison between India and China, 20 years back, we were 0.6 million ton. China was at around 8-9 million tons. They increased it to hopping 46 million ton, and they are now more than 60% of world's aluminum capacity. We also invested and increased our capacity, but we are far below, despite having much superior high quality bauxite reserves than China. And given the projections for Amrit Kal, we should target around 30 million ton of capacity. But as I said, this 30 million ton is a huge number given the capital requirement for aluminum. Now, the theme. As we are talking about 2047, what should be our target for in general metal industry or the mining industry? Right now we are importing around $130 billion of metal and mining products, and our target should be at least to make it zero. Where all we have the resources, we should not import. I mean that's very unfortunate. It's like Kuwait importing oil or we importing thermal coal. It's not a good sign to have. And in terms of GDP contribution, we are currently around 2.5% of our GDP, and we should be targeting at least 10% of GDP if we have to become a global powerhouse in terms of mining and metals space. And we have all the ingredients. We have the strategic locations, we have the skilled manpower, and we have we are blessed with the natural resources. Now this is the last slide. If you see last 30 years from 1990 to now, we have done a remarkable work in terms of extraction of our natural resources, be it coal, iron ores, steel manufacturing, aluminum, or even power. Everywhere we have grown 10 times to 20 times. Somewhere even see like power, it's 70 times. But at the same time, though our exports have grown from 270 billion to 450 billion, our imports have also grown. And if you see what kind of imports have grown, the high-end products, the technology-oriented products. So from now to 2047, what are the key things we need to do? Just not from the government, from our side, from the industry side also. We should be focusing on 4 or 5 things. Not only on the extraction of minerals, but also on the technology. Yesterday I was at my location of Jharsuguda with Dr. Saraswat, DT Ayog member. He asked a very pertinent question. Suppose you have to set up a new aluminum plant tomorrow. Will you still import technology, or you have your own technology developed in India? So that was a very relevant question in terms, are we going to have our own technology for steel manufacturing or aluminum or any other, or we are going to be dependent on the technology transfers? So technology is something, it's not only adoption of technology, but also developing the technology and exporting those technologies. The time will come when countries will stop giving those technology when they see India as a real challenge. Right now they are seeing India as a market, hence they are giving you technology partially. But later on it will be a difficult thing. Also we have to develop an ecosystem for downstream development. Like what's happening today, the steel is getting exported, aluminum getting exported, but are we doing the right value addition in the country? Probably not. Probably if we are not manufacturing Boeings in our country, probably we should be manufacturing parts of Boeings in our country, right? So my earnest request to all members or to our industries, we should not just looking at now the volume, cost and profitability. We should also looking all these to be things where our real progress will depend. With all this, thanks so much.
Thanks, Mr. Himanshu. You highlighted on the quantity part of it and the value which aluminum draws. Many developments have happened on wagons also, rail wagons, which also been tried with aluminum. And net zero, it's a good transition material. With that, I would request Mr. Shantanu Rai to share his views.
A very good afternoon to all of you, respected Secretary Steve, my fellow panelists on the dais, dignitaries of the dais. We are on the cusp of an energy transition, and coal, iron ore and steel are critical for energy transition and continued economic development. In fact, coal, iron ore and steel making have a very intricate connection. Steel sector is hugely dependent on the availability of resources like iron ore, coking on metallurgical coal, steel scrap and power. Steel industry is one of the world's most energy intensive sectors, accounting for around 8 to 9% of the global carbon dioxide emissions. Among the users of coal, which is considered to be the most affordable fuel, majority of it is used in the generation of power and the rest for producing iron, steel and cement. Metallurgical or coking coal, which accounts for almost 40 to 45% of the cost of steel production. The reserves in India are around 35 billion tons, which is not of adequate quality. And thus, we are dependent on imported coking coal, which are subject to wide price fluctuations. The global coal production is around 8.5 billion to 9 billion tons in the next few years, and India is expected to account for around 1/8 of this in the next 2 to 3 years. Iron ore makes up for around 5% of the Earth's crust and is the second most abundant metal after aluminium. And the global iron ore market is expected to reach around 2.7 billion tons in the next few years. India currently ranks 4th globally in terms of iron ore production with around 210 million tons. As already mentioned by one of my fellow speakers, we are targeting a production of 300 million tons of finished steel and 255 million tons of crude steel by 2030. It is very interesting to know that nearly 3 tons of raw material in the form of iron ore and coking coal are needed to produce 1 ton of steel. Hence, for producing 300 million tons of finished steel, we will require 900 million tons of material movement. The world crude steel production is around 2,000 million tons, and India is the second largest crude steel producer in the world, just behind China. One of the major drivers which will drive the growth of the steel industry is the infrastructure. And the infrastructure is driven by rapid urbanization. It is expected that by 2050, the global population will reach around 9.7 billion, with around 70% living in urban areas, which means that every year we'll be looking at having a city of the size of New York for the next 40 years or so. And this will result in huge requirement of steel in the housing and construction sector, which is the largest consumer of steel today and which accounts for more than 50% of the steel products. considering the huge dependence of the steel industry on raw material, there is a strong need to ensure uninterrupted supply of raw material while improving the operating efficiency and quality and reduction in operating cost by digitalization in an integrated and holistic fashion while meeting the long-term targets of carbon neutrality. And the aspiration is that by 2047, in form of green steel, reduce the carbon footprints. Presently, 2.6 tons of carbon dioxide are produced for manufacturing 1 ton of steel, which has to be reduced to 1.3 tons of carbon dioxide per ton of steel. 60% of steel produced through scrap, reduction of coking coal dependence, maximize usage of pellets and 100% gas-based DRI, and green hydrogen and carbon capture and usage, 100% renewable energy for steel production. I represent a company called BML Limited, which is a Ministry of Defense Schedule A CPSE. We are into 3 business verticals: the mining and construction business, the defense and aerospace business, and the rail and metro sector. The company was carved out of the womb of Atmanirbharta in 1964, with the first rail coach manufactured in the country in 1948 at the same place where we are manufacturing our present rail and metro rolling stock. There are 3 signature moves of the company which is defining the BML of today and which has laid the foundation for the BML of tomorrow. The first was entering into a technology collaboration with Komatsu of Japan in 1967 to manufacture the heavy earth moving equipment. 1986, entering into a collaboration with Tatra AS Czech Republic for the manufacture of high mobility vehicles for use by the Indian Army. And 2000, when we entered into the metro segment with the first Delhi Metro in partnership with the erstwhile Coros or Korean Rolling Stock, presently Hyundai Rotem. Since the mining sector, the availability of raw material is one of the most critical factors for the growth of the steel industry, and BML is into the heavy earth moving equipment. Let me just explain to you that in the mining value chain, we are present in 3 value steps. Number 1 is the excavation of the mineral. Number 2 is the stacking, and number 3 is the dumping. So for excavation, we manufacture shovels as well as excavators. For stacking, we manufacture bulldozers. For dumping, we manufacture dump trucks. For leveling the ground, we manufacture motor graders. And we also manufacture water sprinklers so that the particulate matter emission, the particulate matter is controlled in the environment. Our contribution towards Atmanirbharta in the last decade or so has been unparalleled, and we have produced 150-ton AC rear drive dump truck with an engine capacity of 1875 horsepower, which is running in the coal mines. We also have manufactured the first indigenous 190-ton dump truck with AC electric drive, having an engine capacity of 2300 horsepower. The first 180-ton electric excavator that was supplied by us to Singarani Collieries as well as to SECL. We are presently developing the 21 cubic meter rope shovel to be used by Coal India for enhancing its extraction, coal extraction, to 1 billion ton in the next 3 to 4 years. Along with the high-end dump truck, the high-end rope shovel, we are also developing a 550 horsepower motor grader and a 470 horsepower wheel dozer, as well as a 8-ton tire handler, so that the entire gamut of equipment for open cast mining can be produced and developed in the country and supplied to the mining companies. Our support to the steel industry has been there since ages, and our major customers are SAIL, MOIL, NALCO, NMDC, Hindustan Copper, to name a few. In fact, our non-coal segment is having, we are having a fleet of around 1900 equipment in our non-coal segment, out of which the metals and minerals segment accounts for almost 28%, with 50% of that in sale and the balance 25% with NMDC and NALCO. In the coal sector, our contribution to the coal mining as well as to the coking coal mining has been phenomenal. In fact, the total Coal India fleet of the BML fleet of around 3,500 equipment, it consists of around 24% of our fleet, which is used for coking coal extraction in BCCL as well as central coal fields. If you look at our revenue contribution over the last 3 years, the non-coal sector, steel has contributed almost to 45 to 50% of our non-coal sector in the last 3 years.
Mr. Rai, if you can conclude.
Yeah, I'll just end it. We have recently customized our existing excavators to suit the iron ore production in the country. And not only the excavators, but in dump trucks, etc., we are modifying our equipment to suit the industry. Similarly, our efforts towards digitalization has led us to develop products, the AI-based products, including equipment with predictive maintenance, equipment with the driver's fatigue monitoring system, equipment with sensing of the environment so that the water sprinkler can operate automatically. And our contribution and our quest for achieving excellence continues, and so does our commitment to the minerals and metals sector and the steel sector in its quest to achieve 300 million tons of steel production by 2030. Thank you very much.
Thank you, Mr. Rai. You spoke on energy transition, coking coal requirement, iron ore, infrastructure, urbanization, use of scrap and pellets, green hydrogen, renewables, and you also highlighted the importance of BEML in the different domain of coal mining and non-coal mining. So we are waiting for the most expected and beloved speaker, Mr. Nagendranath Sinha. I have a privilege of listening to him in one of the forum in Kolkata, and it's an honor for me to listen to him again. Welcome you, sir, and we would love to listen to your thoughts.
Good afternoon to the esteemed panel on the dais, esteemed dignitaries of the dais, ladies and gentlemen. First of all, let me thank ICC for inviting me to as the chief guest for their Make in India and Steel Outlook session. We have had the privilege of listening to very many eminent speakers who have delved into different aspects of the steel making, mining, technology, and I think all of them have made very valuable points. And after such an illustrious list of panelists and speakers, it's very difficult to add much to what they have said. Nevertheless, let me make some effort. One point which was made by almost every speaker is that iron and steel contribute about 2% of the Indian GDP. And this number, though by itself may be a minuscule, but is the basis and the foundation for all the manufacturing and other activities that takes place in the economy. And the heartening thing is that it's growing, and growing
In fact, the elasticity of growth is more than the growth of the economy by itself, which is what it should happen. The Indian economy last year grew by 6.2%, and however, the consumption of the steel grew almost by 11.9%. Similarly, 13.3%, I'm sorry, it grew from 105.8 to 119.9 million tons. We were seeing, trying to see what was the demand like in the first 2 months of this financial year as compared to last financial year. And we saw that it has grown from 18.8 million ton to about 23.3 million ton, which is about 7.9 percentage point of growth. These are corroborated by the numbers that comes out from the World Steel Association. There may be some point of the methodology. However, the growth that they have mentioned is about 5.7% in this calendar year as compared to the similar period last calendar year. In terms of, if we go by JPC statistics, the growth in the finished steel consumption in this calendar year is about 10.9%. That is taking from January to May. The import intensity and import volumes both are coming down. Good. There are concerns from time to time, and rightly so, that there are instances of dumping from certain countries. However, if you see the quantity is as to the overall extent of consumption gradually as a proportion coming down. However, what is not coming down is the degree of specialty nature of the steel. So for a address for the PLI function, I was looking at the numbers, and we found that this number had grown from somewhere sub 60 to about over 60, something like 65, 66% or so. So the PLI rightly tries to address that, and I'm quite happy to see the confidence in Indian manufacturers who now profess the confidence of producing almost any kind of steel and metals, and also exporting it to the different parts of the country. It is right, until unless you have the necessary confidence, technology, marketing muscle and marketing savvy to market your product in other countries, in the food chain of the steel making, India cannot gain her rightful place, and therefore it is important and necessary that our industries, our manufacturers also have the necessary confidence and technology and wherewithal, etc., to make specialty steel and to be able to almost meet their entire needs. No country, we know that in this time and age, can make all kinds of steel. But to the extent that we are able to make, and this point I have also made earlier, we develop our manufacturing ecosystem. If we only import a particular grade, so all those who are associated with development of technology, manufacturers, supply of spares, technologies, etc., those issues won't come about, and therefore it will only remain incomplete, a flawed kind of a manufacturing capacity, and therefore it is necessary that we also improve our capacity of the steel making in various specialized grades as well. And I'm very happy that industry and government together are making this transition. Abhyuday mentioned to me that just the last week there was this trade fair in Germany called MedTech, and India had a very substantial representation in that trade fair, and that showed the willingness of the Indian manufacturers to get access to the latest technology that is available within the global fraternity. And it is not to undermine the Indian efforts at technology development that is taking place, a point which Santosh Chaurasia made, that we also have large areas of strength. And I think but we should not feel shy of integrating what we have, what we get from abroad and what we develop in India. What should happen is that over a period of time, the mix of Indian technologies, Indian manufacturers developing their own technology, adapting to that, and being able to supply the technology to Indian steel makers should increase, should improve. We currently have a capacity of about 161 million ton within the country. There may be some issues with regard to counting of the capacity, and we can discuss it offline. There are some undercounting happening somewhere. We need to address that. But the fact remains that it is at sub 200, and it needs to go up as the demand itself is galloping. So therefore, the Indian steel makers need to be able to meet the demand, and for this we need to, as per the projection and as per the reality as well, add about 140 million tons additional capacity, and should not be difficult given the announcements that have been made from time to time in public domain and in private conversations. So we are quite hopeful that the Indian steel makers will add this capacity, and that would certainly require a substantial sum of money. If you take a figure of about $1 billion, about 8,000 crore rupees per million metric ton of addition development of new capacity, so that 140 million ton, it's about 12 lakh crores or so. So it's a substantial sum, but it's not an insurmountable sum, given the fact that the Indian banking system now has said its hangover resulting from the NPAs. Now it's surplus with liquidity, and you have the 100% FDI available in the steel sector, and there are policies, many of which have been mentioned, and I need not. So I was mentioning that the availability of funds for financing the expansion should not prove difficult given the status of the banking sector as well as the policies around it. There are at times questions asked as to whether we have the necessary visibility of demand, but I think what has happened at least in last 3 years is that the expansion and the funds for the development of infrastructure has been growing at a rate of about 18% CAGR. And in my own memory, I think in 21-22 it was somewhere in the range of 4.5 lakh crores. In 22-23 it became 7.5 lakh crores. And this year capex by the central ministries itself is about 10 lakh crores. And if you see the overall number, which includes transfers as well as PSU capex, etc. So those numbers are something like 13.7 lakh crores, which is about 4.5% of the capex, which is publicly funded. And if you add to that the capex that is also being financed by the private sector, so that certainly adds to a very tidy number. So I won't delve into detail in this regard. We just wanted to illustrate the fact that the government is pushing the infrastructure development. A related point which I wanted to mention is I was looking at the 3 years numbers again with regard to the type of uses of steel in last 3 years. And what I found striking is that the proportion on each segment is constant over last 3 years. It's not, the ratio is not changing. For example, if you take building and construction, it's about 42%. If you take the infrastructure, it's about 25 to 26%. If you take manufacture and packaging, so it's about 22%. The one on defense is about 1%, auto is about 9% or so, and this number is remaining constant over last 3 years. So that is to say that other parts of the economy are also growing almost in a similar manner, and the demand seems to be pulling in a similar trajectory in all the areas. There was this point made by Mr. Rao, and in great detail, about the issue of handling of logistics. And he very rightly mentioned that if we want to handle about 500 million ton of iron and steel manufacture, then that would mean carriage of about 2 billion tons of products and inputs, which is a very large number as compared to what their current capacity is. So it is not that the railway is not adding capacity. As per the numbers that we get from the railway ministry, last year itself they added about 5,000 kilometers of new railway lines. Under the Gati Shakti plan, they have taken up they are taking up many projects, and we have also provided to them a list of about 22 projects. And when the finance ministry wanted to scrutinize their budget proposal, they also sought from us a list of projects that could help the steel industry to move their goods and get their goods. So we provided, after consultation with the steel makers, another list of about 20 odd projects. On top of that, they are also adding about 2,000 to 2,500 wagons per month. So they are also increasing their capacity, but the fact remains that we have to also think out of the box to acquire the necessary logistics capacity, because if we depend on just the tried and tested, it may not work out, and we have to free up capacity in the country's own logistics network. I'm very happy to add to what Mr. Rao mentioned of working with the Railway Ministry with the Gati Shakti plan of supporting the development of a slurry pipeline network. So Railway Ministry had initially accepted, as he mentioned, but since they have been furiously adding to their capacity, so there has been some rethink, because now there is a thinking that this capacity slurry pipeline, if it comes about, it will displace their existing carriage capacity, and to that extent it will remain idle. But I think it's a very short-termist thinking. In the long run, in the medium run, each transporter has so much to carry that they would have their plates full if they do justice to that. So we will be, we are working with the Railway Ministry. We have taken one project as a proof of demonstration with the Railway Ministry, in which the entire ROW lies in the along the railway line, and we will try to see if we are able to meet all the issues that the Railway Ministry have in this regard, and if we need to modify anything in order to achieve and receive the acceptance of the Railway Ministry. Yes, that the suggestion made by him in form of the National Slurry Pipeline Grid is a valuable document, and unfortunately we didn't have access to that document, and now that he has mentioned such a document exists with MECAN as well as in the Steel Ministry, we'll dust that out and we'll look at that. To us, what excites us is the fact that if we could think slurry pipeline as a public utility, that happens, that would be a great development, because what we have seen with whatever rule of thumb calculations that we have made is that once you increase the capacity of the slurry pipeline, the capex unit cost per unit of movement in terms of capex as well as opex falls and becomes economic for everyone to carry at even a lower cost, both in terms of the actual expenditure incurred as well as the carbon emissions saved, etc., and the environmental costs. So it's a great thought, but there are multiple challenges in terms of its acceptance and its realization. So we'll have a task cut out in order to formulate, conceptualize, sell, and then win acceptance of everyone. But the logistics wing of the DPIIT seems quite keen, and so we think we will be able to move ahead. Next, I take the issue of the technology, particularly arising out of the issue of the decarbonization, and the decarbonization agenda is proceeding very fast, and on top of that there are developments across the world where because of considerations which are now being attached to the trade, the Indian manufacturers will have to up their game in order to be more productive, less carbon emitting, and improve their efficiency of production quickly. many levers have been mentioned, including the adoption of digital technologies, Industry 4.0, material efficiency, energy efficiency, RE, the hydrogen, CCUS, etc. So all these levers of technologies are being looked into by a group of 13 task forces that the ministry has commissioned on these issues. And these task forces were constituted sometime in April this year, and they have been given 3 months time to complete their work. And once we get their report, we will synthesize their recommendations and see what kind of policies and levers that we can have, which leads to accelerated decarbonization within the limits of sustainability within the country, and what we need to do and the policies that we have, so that we not only have decarbonization proceeding for the sector as a whole, but also to ensure that the decarbonization is also inclusive. It will be quite a tragedy if our small and medium steel makers are not able to stand the challenge of decarbonization. So quite a difficult task ahead of all of us, for the academia, for the research and development institution, as well as for the industry also. Because sometimes we feel that there is ultimately the government which will come and save certain industries. But now the economic reality is now changed very substantially. I think what you can expect is that there would be help, there would be support, there would be supportive policies, but it will not be possible for the industry and possible for the government to extend a hand which provides financial support or things of that kind, so that industry which would otherwise not survive will be helped to survive. So there would be a partnership, and this partnership would try to help all the steel players and would try to ensure that the small and medium steel makers also survive, and they also adopt the latest techniques in their domain, and they modify their working practices. They are alive to the demands of the improvement in technology. And as Mr. Rao mentioned, that those who fail to read the line in which the technology is developing, they may not survive, and therefore it is important for associations like ICC also to work with the steel makers of small and medium variety, so that they are also able to get advantage of the new technological developments. I would address two more issues and thereafter I stop. One issue which was mentioned by Abhyuday while we were talking before coming to this session was the issue of the manpower. And there is a shortage of manpower in this sector, particularly when many industries want to expand and many industries want to adopt the new technologies. Unfortunately, the way our industry has progressed so far is that there were not many jobs available for the people who studied mining and metallurgy, and therefore there has been a tendency for most of the students to move away from the mining and metallurgy, and they're hardly interested. So we'll have to work with the academia and also improve our attractiveness through attractive HR policies, salaries, and other issues, and reach out to the academic institutions not only at the time of when they graduate and are looking for job, but also earlier, so that the tendency for migration from these branches to areas which are evergreen like IT, etc., that stops. So and that is at least not as much of a retarding factor in availability of manpower. But and this issue is also important for development of the manpower at operating levels as well. So the ministry is working towards this area by reactivating the Biju Patnaik National Steel Institute, and through which particularly the small and medium steel makers and those of large steel makers who want to utilize those facilities to train their operating manpower, those could be provided those support in addition to what we can get from the NISST. Another area which was mentioned to me by Tata Steel Research and Development Center, that there is a shortage of process metallurgists within the country and who are capable of undertaking research in this regard. So there are very few. Even if you want to hire and set up your own research and development institution, there are very few PhD students, MTech students in those areas, and there are very few researchers and professors to guide them. So this is one area which we'll have to meet. We are trying to work on this issue along with the Ministry of Mines, because at the level of mining departments within those academic institutions, there is hardly any difference between the ferrous and non-ferrous metallurgy, and so we plan to work together. Another area which I want to mention is the issue of the suppliers of machineries and supplies for the steel making, and I'm sure this would also be valid for the aluminum sector as well. For example, the rollers which is used in the cold rolling mills, etc., is what we are not able to get within the country. There are few, one or two manufacturers. There were few earlier, but they withered away, and most of it is supplied from China and other countries. Similarly, refractories, quite a lot of it is imported. And similarly, there are a list of about 5,000 odd products which are needed for the steel manufacturer, and I'm sure a similar list could be compiled for the non-ferrous metallurgy as well. I think associations like ICC also need to address this issue of development of capacities for manufacture of these complex of these kind of equipments and supplies, so that to the extent feasible, India has the necessary capacities in the manufacture of these items, and we are able to be as much dependent on ourselves and compete at an equal footing in the international market. And why should we not? Because we are the second largest steel makers, and to think that a company in Austria would be supplying when their own production capacity is 4 million ton as compared to your country like India, which has 40 times more capacity. I'm just giving an example. So we also need to develop this capacity. In the end, I would like to mention that the outlook of the metal sector and particularly the steel sector is very bright. You play a very vital role for the India's development, and in your strength lies the strength of the country, and there is a need for forging greater partnership and cooperation between both industry, the government, the financial institution, the technical institutions, so that as a whole we are able to traverse this journey with as little pain as possible. Thank you very much.
Thank you, sir. So, Mr. Sinha highlighted many points, starting from data of finished steel products, import intensity, especially steel concern, and then how PLI is going to address this, manufacturing ecosystem, and the confidence in steel players that they will do the value addition, capacity enhancement to meet the target. He also highlighted the presence of steel players in global trade fairs. Points raised by previous speakers on logistics, slurry pipeline, less carbon intensive industry, energy efficiency, resource efficiency, digital technology, industry 4.0, CCUS, and skilled manpower, process metallurgist, and supply of machineries. So almost all the points which have been spoken by the previous speakers, as well as the concerns area which have been in the thought of the persons who are attending this seminar, were addressed by Secretary Steel. Before we proceed further, we can take 2 or 3 questions from the audience if they have. So,
P.K. Chatterjee from Indian Institute of Metals. Sir, my question is directed to Secretary Steel. Sir, the Department of Steel has set up a very ambitious target of producing 300 million ton by 2030. Very encouraging. But whether that quantity includes the production from induction furnace route also, because in that case, that sector has to be squarely brought under quality control order. Otherwise, we may reach the target of 300 million ton or very near to that figure, but we will end up with a product mix of standard and substandard quality. Sir.
So we'll take the questions together and then he will answer. Yes.
Sir, IMMT. Sir, you have raised a right question regarding the human resources development or the manpower in the Indian minerals sector. Actually, we have expertise in mineral beneficiation, etc. But the students getting passed from ISM or some engineering colleges in this area, they are not having a right kind of jobs. So I would like to request the industries also, you please try to recruit the people who are having the domain knowledge in this area. No doubt that there is a lack of expertise in the field, but also the industries, you please encourage those who are having the domain knowledge.
Thank you. Last question, I think someone. Yeah.
I'm Rajiv Agrawal, Secretary General for Indian Captive Power Producers Association. I like to highlight upside down cost structure for industry as a whole in India. which is also severely affecting steel. Sir, you mentioned that no financial incentives should be expected. I'm with you. But at the same time, industry is being to pay cross subsidization through various stages at various stages. Another point is energy, which is on purchasing power parity is 5 to 8 times costlier than other places. That is a key reason, according to my analysis, that people are not able to afford even basic housing using steel and cement. And that is not creating a consistent demand which such a large number of people, means 1.4 billion people, should have done. Now, I give you an example. Railway is taking almost like 50 to 70% cross subsidization on coal. I'm not talking of rest of the other products, industrial products. I'm talking of say 400 rupees cess on coal. I'm talking of almost 25% cumulative of royalties, etc., plus other taxes. Now, these are the things. I'm not talking of like inefficiencies of Coal India and how bad things are and how costly the things are. Even if I don't do it, these are the things where government is taking money from, extracting money, giving something free, but that is again a negative game. Thank you.
I think the second question was by way of observation rather than a question, so I need not respond to that. So it's an appeal, and I think a very right appeal to all the dignitaries and all the captains of the industry in the house. The first question is about the inclusion of the induction furnace production within the overall production. Yes, they are as much a part of the overall production as the other routes of production are. So certainly within 300 million tons, those are included. And I'm not sure if they are not included within the QCOs. They are as much, QCOs are applicable to all products irrespective of the origin. So there may be a flaw in my understanding, but from the broad understanding that I have got, QCOs are applicable irrespective of the source of steel making. So nevertheless, the point that you have made, we'll see. I can have a discussion with you offline and then try to see if there is still there are issues which I have not been able to spot. The third point was, it's a very general point, and it will not be possible for me to refute that point, because that's what the structure of the Indian economy is, and this is how the railway has been operating for quite a while. There has been a cross subsidization between the passenger and the freight. You are aware that it's only about 57 to 58% of the total passenger costs are recovered from the passengers, whereas the rest is cross subsidized. So there is this issue, and hopefully as we progress up the prosperity ladder, this goes down, and there is a greater realization that the such kind of cross subsidization is not very helpful to the competitiveness of the Indian industry. So it can only come about gradually rather than.
So thank you very much. Now we have come to the end of the session. It's my duty to say a vote of thanks to all those who have contributed, participated, heard, observed, analyzed. But what I could make out with the different dynamics, different wish list, different thoughts, and different projections in terms of the scenario planning and the changes what going to happen. It reminds me a famous couplet of Ahmad Faraz कि किस तरफ को चली है अब हवा नहीं मालूम, हाथ उठा लिए हैं सबने पर दुआ नहीं मालूम, मंजिलों की तब्दीली बस नज़र में रहती है, हम भी होते जाते हैं क्या से क्या नहीं मालूम. So sometimes you are asked to work on decarbonization, sometimes on cost, sometimes on logistics, and we are trying to meet all the expectations made by the different quarters. And again, I would like to conclude with Bhagavad Gita, chapter 6, slok 25, that Shane Shane Upramit Buddhya Dhridigritaya Munah Kitva na Kinchit api Chintayet. Shane Shane means slowly, step by step. Upramit, increase or improve our intellect with patience so that we can overcome the challenges the steel industry is facing. With that context, I would like to thank Secretary Steel, Sri Nagendranath Sinha, who has given a lot of insights today, almost touched every aspect of steel making and the challenges what we are facing, which I spoke after end of his speech. Mr. Abhyuday Jindal, he is there with us throughout the day, right in the first session and today also in afternoon session. I thank you, Mr. Jindal, for being with us and sharing your valuable insights and inputs. Mr. Agrawal was attending the session online, and I thank him also. And Rao Sahab has made many points which we discussed, and I also reiterated. Thank you very much, sir, for being part of the session. Mr. Santanu Rai, he also spoke lot of issues on iron ore and BML, the domain what they are going to serve and are still serving in coal and non-coal mines. Thank you very much, Mr. Rai, for being part of it. And Mr. Himanshu Singh, he was saying earlier that मेरे को steel वालों के बीच में क्यों बैठा दिया? But you are part of our manufacturing, you are part of our industry, and your insights are also very helpful to us because many a times cross-learning helps. So we see even in our children book stories that the wheel was invented much before. But if you see the application of wheel in suitcase is hardly 30 years. So many people would have thought of knowing the journey of wheel, but implementation of wheel in the luggage is very recent. So your presence also has helped us. We saw many insights, the quantity what you are handling in raw material. And also my thanks goes to all the audience who have been here, my friends from media, and most important, the organizers of ICC who have been preparing for this seminar from past 2 months. So Ananya, Nilanjan, and Mr. Singh, thank you very much.
Thank you so much, sir. And on this note, I would request Mr. Abhyuday Jindal, Vice President ICC, to kindly hand over token of appreciation to the Honorable Steel Secretary, Sri Nagendranath Sinha ji. I would a memento for Mr. N.D. Rao. Mr. Pankaj Satija. Mr. Shantanu Roy. And Mr. Himanshu Singh. On this note, we'll close here. I would like to thank each and everyone present here today with us for being with us since morning. It was really a wonderful session, and we look forward to meet you again in the 13th edition of this initiative next year. Thank you.